We begin with the earliest years of Albert Einstein, the child who would later become the most famous scientist in the world. Born in the German city of Ulm on March 14, 1879, he entered life in a quiet household that was not especially wealthy or powerful, but one that carried a deep respect for knowledge, education, and persistence. His father, Hermann Einstein, worked as a salesman and later managed an electrochemical business, while his mother, Pauline, nurtured a love of music and culture within the family. From the beginning, Albert's upbringing combined the values of practical work and intellectual curiosity, a mixture that would shape the foundation of his remarkable journey. The Germany into which Einstein was born was rapidly changing. The Industrial Revolution was transforming cities, trade, and technology. Scientific discoveries were beginning to reshape how ordinary people lived, from electricity to new methods of communication. While Ulm itself was a modest city, the air of progress was present. Hermann and Pauline, like many parents of the late 19th century, hoped their son would benefit from these changes and find opportunities that they themselves had not fully enjoyed. Yet, in his earliest years, Albert did not appear exceptional to outsiders. In fact, stories circulated within the family that he was slow to speak. Some relatives worried he might never develop normally. His mother, however, was patient, and she trusted that his quiet nature was not a flaw, but a stage of growth. By the time Albert began to speak, his way of thinking already seemed unusual. He preferred to contemplate before answering, and even as a child, he was reluctant to accept statements at face value. Family anecdotes tell of his fascination with objects as simple as a compass, which he received at the age of 5. Watching the needle point steadily north, unaffected by touch or movement, left him deeply impressed. The invisible forces that guided the needle seemed magical, but to young Albert, they also hinted at mysteries of nature waiting to be explained. That sense of wonder never left him, and in later years, he would recall the compass as one of his earliest sparks of curiosity about the hidden laws of the universe. Education for Albert began at home and then at a Catholic elementary school in Munich, where the family had moved shortly after his birth. Although his family was Jewish, he attended this Catholic institution without difficulty, learning basic subjects such as arithmetic, reading, and writing. Teachers described him as quiet but diligent, often lost in thought. His performance was solid but not outstanding, in the sense that he towered over classmates. Rather, what stood out was his persistence in following problems to their end. He did not easily memorize material for recitation, as was common in German schools. Instead, he wanted to understand why rules and answers worked. This trait often made him appear stubborn to teachers, but it also signaled the beginnings of a mind that valued comprehension over rote learning. Meanwhile, the Einstein household fostered a culture of study beyond school. Albert's mother encouraged him in music, and he began violin lessons, which became a lifelong passion. Though he sometimes resisted practice, he gradually grew to love the instrument, finding in music both emotional release and intellectual stimulation. His father and uncle, on the other hand, supplied him with books on science and mathematics. His uncle Jacob, in particular, played an important role in guiding him toward more advanced material than what was offered in school. By the age of 12, Albert had already encountered concepts in mathematics that went far beyond his grade level. He taught himself geometry and algebra, finding joy in solving equations and marveling at the logical beauty of mathematics. Despite this supportive environment, Albert also faced challenges. The rigid structure of German schooling often clashed with his independent style of thought. Teachers expected strict discipline and unquestioning obedience, but Albert questioned authority and disliked rote drills. One teacher is reported to have told him that he would never amount to anything, a judgment that reflected more about the teacher's frustration than the boy's potential. Einstein's family noticed his discontent, and these early clashes with authority left a lasting mark on him. Later in life, he often spoke critically of strict systems of education that suppressed creativity in favor of conformity. Outside of school, Albert's world expanded through books. He devoured works of popular science, philosophy, and mathematics, always searching for material that challenged him to think deeper. One influential text was a book on geometry, given to him at a young age. The precision and clarity of geometric proofs fascinated him, as he saw how logic alone could lead to undeniable truths. This experience strengthened his faith in reason, as a tool for uncovering the hidden order of the universe. By the time he reached his teenage years, his intellectual independence was unmistakable, even though outwardly he still seemed like an ordinary student. The family's fortunes, however, were less stable. Hermann Einstein's business ventures struggled, and eventually the family faced financial difficulties. When Albert was still young, the family relocated from Munich to Italy, seeking new opportunities. This move disrupted his education and placed him in a period of transition. He briefly stayed behind in Munich to continue schooling, but his unhappiness with the rigid academic environment grew unbearable. Eventually, he rejoined his family in Italy, effectively leaving formal schooling in Germany behind. This decision marked an important break from conventional paths. Though it created uncertainty about his future, it also freed him from an environment that had stifled his natural curiosity. In Italy, Albert spent time exploring the countryside, reading independently, and continuing his studies without direct supervision. He grew more confident in his ability to guide his own learning. Soon, he made a pivotal choice. He would pursue further education in Switzerland, where schools were reputed to be more flexible and open-minded. This plan would eventually lead him to the Polytechnic School in Zurich, setting the stage for the next phase of his development. But before reaching Zurich, Albert had to prove himself through rigorous entrance exams, a challenge that would test both his strengths and weaknesses. These early years in Germany and Italy reveal much about the foundations of Einstein's character. His quiet but deep curiosity, his resistance to rigid authority, and his ability to teach himself complex material all foreshadowed the qualities that would later define his scientific genius. Though his childhood seemed unremarkable in many ways, the seeds of greatness were already present. In the next segment, we will follow him into his Swiss years, where the young Einstein would begin to transform from a curious boy into a serious student of science. When the Einstein family relocated to Italy, Albert was at a crossroads. He was a teenager without a formal school placement, and the traditional German system had not suited him. Yet, he remained determined to continue his education, and his ambitions focused on entering the prestigious Swiss Federal Polytechnic School in Zurich, often referred to simply as the Polytechnic. To achieve this, however, he first needed to pass an entrance examination. This exam was demanding, covering a broad range of subjects, and Einstein's strengths and weaknesses were about to be revealed in stark detail. In 1895, at just 16 years old, Einstein traveled to Zurich to take the exam. The results were mixed. He excelled in mathematics and physics, performing well above expectations. His grasp of these subjects was already at the level of advanced students, showing how much he had absorbed through independent study and his uncle Jakob's guidance. But in other areas, particularly languages, history, and subjects requiring memorization, he fell short. His performance in those fields was not strong enough to gain admission directly to the Polytechnic. Rather than rejecting him outright, however, the school saw his potential and offered a path forward. Einstein was advised to attend a preparatory school in the town of Aarau, Switzerland, to improve his general education before reattempting admission. This decision proved to be a turning point in his life. The year he spent in Aarau exposed him to a style of education radically different from the rigid systems he had experienced in Germany. At the Aarau school, teaching emphasized critical thinking, creativity, and personal responsibility. Students were encouraged to question, to discuss, and to develop their own understanding rather than simply recite memorized material. This environment suited Einstein perfectly. For the first time, he felt at home in an academic setting, and he thrived under teachers who valued curiosity. He also formed friendships with classmates who appreciated his wit, independence, and sharp mind. One of the more interesting glimpses into Einstein's time in Unraveled comes from a paper he wrote describing his vision of life's purpose. Even at this young age, he reflected on the balance between individuality and community, noting that while people have personal desires, they also must contribute to the well-being of society. These reflections reveal the early beginnings of the humanitarian outlook that would later shape his views on politics and ethics, alongside his scientific pursuits. Unraveled also gave Einstein the opportunity to engage in imaginative thinking. It was here, according to later recollections, that he first began experimenting with thought experiments, a technique he would rely on for much of his career. One famous example involved imagining what it would be like to chase a beam of light. This seemingly simple mental exercise planted the seeds of ideas that would later develop into the theory of relativity. Though he did not yet have the mathematical tools to explore such questions in depth, the curiosity was already alive and active in his teenage years. After successfully completing his year in Aachen, Einstein returned to Zurich and was admitted to the Polytechnic in 1896. At 17, he entered as one of the youngest students. His admission marked the official start of his formal scientific education. And while the years ahead would be filled with both triumphs and frustrations, this moment was the gateway to his transformation from a gifted student into a professional physicist. Life at the Polytechnic presented both opportunities and challenges. Einstein enrolled in a program that trained students to become teachers in mathematics and physics. His professors included several respected scientists of the time, and the school provided access to advanced laboratories, libraries, and discussions. However, Einstein's independent nature sometimes clashed with the structured curriculum. He often skipped classes he considered dull, preferring to study on his own or pursue subjects that caught his interest. His notes reveal a mixture of discipline and spontaneity, with detailed work in physics, but gaps in areas he found less compelling. Despite these tendencies, Einstein continued to demonstrate brilliance in mathematics and physics. He absorbed the works of great scientists like James Clerk Maxwell, whose equations on electromagnetism deeply influenced him. The unification of electricity, magnetism, and light under Maxwell's framework fascinated Einstein, and he studied these concepts intensely. His exposure to these ideas would later be crucial in the development of his own revolutionary theories. At the same time, Einstein was also influenced by philosophy. He read works by Immanuel Kant, Baruch Spinoza, and David Hume, among others. These writings shaped his approach to thinking about science, grounding his questions in both logic and broader reflections on reality. Philosophy helped him consider not only how things worked, but also why science should be pursued and what knowledge meant in human terms. This blend of rigorous physics and reflective philosophy gave him a distinctive perspective compared to many of his peers. Socially, Einstein's time in Zurich was lively but also complex. He formed close friendships with fellow students, including Mileva Maric, a Serbian physics student who would later become his first wife. Their relationship was both intellectual and personal, with Mileva serving as a companion in discussions about physics and mathematics. Their correspondence shows how deeply they engaged with scientific questions together, though the challenges of personal life would later complicate their story. For now, however, Mileva was one of the few people who matched Einstein's intensity of thought, and their bond was strong. Einstein's years at the Polytechnic were not free of difficulties. His independent attitude sometimes annoyed professors, and he did not always follow the expected academic paths. Some teachers viewed him as careless or lazy because he resisted rote work and formalities. When he graduated in 1900, his academic record was respectable, but not outstanding by the school's standards. His professors did not rank him among the top candidates, and this would have significant consequences for his immediate future. Instead of stepping directly into a teaching or research position, Einstein faced years of uncertainty and rejection, struggling to find employment in academia. Looking back, it is clear that the Polytechnic years were crucial in shaping Einstein's identity as both a scientist and a thinker. He developed his intellectual tools, absorbed the physics and mathematics of the time, and refined his method of using thought experiments to probe the nature of reality. At the same time, he learned that authority and reputation would not always favor him, and that he would need resilience to pursue his ideas. As Einstein left the Polytechnic, he was full of potential, but also uncertain about his path. His brilliance was obvious, yet the academic world had not fully embraced him. The next chapter of his life would take him into unexpected territory as he searched for work, endured rejection, and eventually found stability in an unlikely place, the Swiss Patent Office. It was there, outside the traditional academic system, that Einstein would produce some of the most groundbreaking scientific work ever written. By the time he graduated in 1900, Einstein had sharpened his mind, gained a deep appreciation for physics and philosophy, and proven his ability to think independently. Yet his academic record was uneven, and his unconventional style of learning left many professors unimpressed. What came next was a period of uncertainty and frustration, a chapter in his life where he faced rejection after rejection before finding stability in an unexpected place. Graduating from the Polytechnic should have been a moment of triumph. For many students, the degree was a ticket to secure employment, often through teaching posts or assistantships offered by professors. But Einstein's reputation among faculty was mixed. Several professors felt he lacked discipline, and because he often skipped lectures, he failed to build strong personal relationships with them. In an academic world where recommendations carried great weight, this lack of support proved damaging. When Einstein applied for assistant positions at universities, his applications were repeatedly overlooked in favor of other graduates whose professors spoke more highly of them. The years immediately following graduation were marked by disappointment. Einstein took on short-term tutoring jobs, working with students who needed help in mathematics or physics. These roles were far from stable, and the pay was modest. He also attempted to secure teaching posts at schools, but found little success. His frustrations grew as he watched former classmates step into respectable academic positions, while he struggled to find even a foothold. Adding to the pressure was his personal life. During his years at the Polytechnic, Einstein had grown close to Mileva Maric, his fellow physics student. After graduation, their relationship continued. But it was complicated by financial difficulties and the disapproval of Einstein's parents. Mileva came from a Serbian background, and Pauline Einstein worried that she was not the right match for her son. Despite these tensions, Albert remained committed to Mileva, though their union added further responsibility to a life already filled with uncertainty. By 1901, Einstein's situation seemed bleak. He had applied to numerous academic positions and been rejected from all of them. He even briefly considered abandoning his pursuit of a scientific career. At the same time, however, he continued to work on physics privately. His mind never stopped turning over the great questions that fascinated him. Questions about light, energy, and the fundamental laws of nature. In this sense, while his career stalled, his intellectual growth continued. A temporary opportunity arrived when Einstein worked as a substitute teacher in Winterthur and Schaffhausen, Swiss towns that gave him short-term posts. He used these jobs to earn money and stay connected to science, but they did not lead to permanent roles. Then, in 1902, his fortunes changed unexpectedly. Through a recommendation from a friend, Einstein secured a position at the Swiss Patent Office in Bern. The patent office job was not glamorous. Officially titled a technical examiner, Einstein's role involved reviewing patent applications for devices and inventions, particularly those related to electromechanics. His task was to evaluate whether proposed inventions were truly novel and workable. The job required precision and careful analysis, but it was far removed from the research environment Einstein had hoped to enter. Still, the position offered steady income and stability, something he had sorely lacked for 2 years. While at first it may have seemed like a detour from his scientific ambitions, the patent office would become the unlikely stage for Einstein's greatest intellectual breakthroughs. The work demanded that he think critically about the principles behind machines and electrical systems, and this daily exposure sharpened his ability to analyze complex problems. More importantly, the job left him with free evenings and weekends, time he devoted entirely to theoretical physics. During his early years at the patent office, Einstein settled into a routine. He worked diligently during office hours, earning a reputation among colleagues for his thoroughness and independence. Outside of work, he joined a small circle of friends with whom he discussed science, philosophy, and politics. This group, known as the Olympia Academy, included fellow intellectuals such as Maurice Solowin and Conrad Habicht. They read and debated works from thinkers like Henri Poincaré, Ernst Mach, and David Hume. These discussions broadened Einstein's horizons and fed his insatiable curiosity. Financial stability also allowed Einstein to take important personal steps. In 1903, he married Mileva Maric, solidifying their relationship despite his family's reservations. Their life together was modest, marked by the typical struggles of a young couple living on limited income. They Clay welcomed their first son, Hans Albert, in 1904. Life was not always easy, but for the first time since graduation, Einstein had both professional stability and a growing family. Even as he settled into this life, his scientific mind remained restless. He began writing papers in his spare time, exploring questions that had lingered since his student years. Between 1902 and 1904, he published a handful of papers on topics such as molecular forces and thermodynamics. These early works did not bring him fame, but they established him as a serious thinker in scientific circles. They also built his confidence, showing him that even without university backing, he could contribute meaningfully to physics. The stage was set for what would become the most extraordinary period of productivity in his entire career. In 1905, while still working at the patent office, Einstein would publish 4 papers that would transform physics forever. These works, covering the photoelectric effect, Brownian motion, special relativity, and the equivalence of mass and energy, would come to be known collectively as his Annus Mirabilis, or Miracle Year. But before that explosion of ideas, it is important to understand how the struggles of his early career shaped him. The rejection by universities forced him to work independently, free from the influence of academic hierarchies. The patent office gave him time, space, and security to pursue his ideas without pressure to conform to prevailing theories. And his personal resilience, tested by setbacks, prepared him for the persistence required to challenge the scientific establishment. In many ways, Einstein's failures after graduation were just as important as his later successes. They forged his independence, strengthened his determination, and set the stage for the revolutionary insights that would soon follow. The quiet years in Bern, seemingly obscure at the time, were the incubation period of ideas that would alter humanity's understanding of the universe. In 1905, while working full-time at the Swiss Patent Office in Bern, Albert Einstein entered the most productive period of his early career. Within the span of a single year, he published 4 scientific papers in the journal Annalen der Physik. Each paper addressed a major unresolved question in physics, and together they marked the beginning of modern theoretical science. What made this achievement all the more remarkable was that it came not from a university laboratory or a tenured professor, but from a young patent examiner who worked on his research during evenings and weekends. The first of these papers, submitted in March, examined the photoelectric effect. At the time, physicists were struggling to understand why light shining on a metal surface could eject. According to classical wave theory, the intensity of light should determine whether electrons were emitted, but experiments showed that below a certain frequency, no electrons were released, regardless of the brightness. Einstein proposed that light did not behave solely as a wave, but was also composed of discrete packets of energy, later called photons. The energy of each photon depended on its frequency, and only photons with sufficient energy could dislodge electrons from a metal surface. This idea challenged the prevailing view of light and laid the groundwork for what became quantum theory. In May, he published a paper on Brownian motion. Observers had long noted the erratic, jittery movement of tiny particles suspended in liquid, a phenomenon first described by Robert Brown in the early 19th century. Many suspected that the motion was caused by collisions with invisible molecules, but proof had remained elusive. Einstein used statistical mechanics to show mathematically how the random impacts of countless molecules could produce the observed movements. His analysis provided a way to measure the size of atoms and molecules, offering strong evidence that matter was composed of these fundamental particles. This contribution effectively ended lingering doubts about the existence of atoms. The third paper, submitted in June, introduced the special theory of relativity. The issue at stake was the nature of motion and the behavior of light. James Clerk Maxwell's equations described light as an electromagnetic wave that always moved at the same speed, yet classical mechanics suggested that motion should alter the measured speed of any wave. For decades, physicists had searched for an explanation, often invoking the idea of a mysterious ether that filled space. Einstein abandoned the ether entirely and proposed 2 principles. The laws of physics are the same for all observers moving at constant speed, and the speed of light is constant for everyone, regardless of their motion. From these simple statements flowed extraordinary conclusions. Time and space were not absolute but relative to the observer. Events that seemed simultaneous to one person might not be simultaneous to another. Moving clocks would tick more slowly, and lengths would contract in the direction of motion. These effects, though strange, were logical consequences of his assumptions, and they resolved the inconsistencies between mechanics and electromagnetism. In September, Einstein followed with a short but profound paper extending the implications of relativity. He demonstrated that mass and energy were equivalent, connected by the simple but powerful formula E mc². This relationship meant that matter itself could be transformed into vast quantities of energy, and vice versa. At the time, Einstein viewed this as an elegant theoretical insight rather than a practical discovery, but it would later become central to both nuclear power and weaponry. The four papers of 1905 addressed different problems, but were united by their originality and boldness. Each tackled a subject that had resisted explanation and offered a new framework for understanding it. Collectively, they reshaped physics, pushing the discipline beyond the boundaries of classical theory and into new territory. The scientific community began to take notice. Though Einstein was still a little-known patent clerk, his papers attracted attention from leading physicists. Some were skeptical, particularly of his proposal that light was made of particles. Others, such as Max Planck in Berlin, recognized the significance of his ideas and began to correspond with him. The theory of relativity, in particular, stirred debate. Its rejection of absolute space and time challenged deeply held assumptions, yet its mathematical clarity and consistency made it difficult to dismiss. For Einstein personally, 1905 was a turning point. He had proven that he could make contributions at the highest level of science without institutional backing. His evenings at the kitchen table, writing after a day at the patent office, had produced papers that would influence generations of scientists. Although fame and recognition came slowly, the miracle year established him as a figure of growing importance in the scientific world. Life at home remained modest. He continued his duties at the patent office, supporting his wife Mileva and their young son Hans Albert. Their apartment in Bern was small and unremarkable, but within its walls, ideas were forming that would change the understanding of the universe. Einstein's circle of friends, the so-called Olympia Academy, celebrated his success, reading and discussing not only scientific works, but also philosophy and literature. Their conversations reflected the breadth of Einstein's interests and his conviction that science was connected to broader questions of existence. The momentum created in 1905 carried Einstein into a new phase of his career. Over the next few years, he continued to publish, refine his theories, and slowly gain academic recognition. Universities that had once ignored him began to take notice. The patent clerk in Bern was on his way to becoming a central figure in international science, though the journey ahead would still bring struggles, both personal and professional, before his position was secure. In the years following 1905, Albert Einstein's reputation within the scientific community began to grow steadily. His groundbreaking papers had appeared in a respected journal, and while not all physicists immediately accepted his conclusions, his work could not be ignored. Discussions of relativity, the photoelectric effect, and Brownian motion spread through universities and laboratories across Europe. Slowly, the name of a young patent clerk in Bern became associated with some of the most important questions in physics. Einstein remained at the patent office through these early years of recognition. The job continued to provide financial stability, and he carried out his duties conscientiously. His colleagues described him as diligent and approachable, though his passion clearly lay in the manuscripts he prepared outside of work hours. The contrast between his daytime routine and his evening research created a dual existence. During the day, he reviewed patent applications for mechanical devices. In the evenings, he developed theories that would reshape the foundations of science. By 1907, Einstein had expanded his work on relativity, considering how the theory might be extended to include acceleration and gravity. These ideas, which would eventually culminate in general relativity, consumed much of his attention. But his progress did not stop him from pursuing other topics. He published papers on specific heat, quantum theory, and radiation, gradually broadening the impact of his contributions. His willingness to move across fields set him apart from many contemporaries, who tended to specialize narrowly. The recognition of his work translated into academic opportunities. In 1908, Einstein secured a position as a lecturer at the University of Bern. It was his first formal academic role, and although the appointment was modest, it marked the beginning of his departure from the patent office. His lectures attracted attention from students who found his approach clear and inspiring. He preferred informal discussions over rigid classroom structures, encouraging his students to ask questions and think critically about established theories. His career advanced further in 1909, when he was offered a professorship at the University of Zurich. Leaving behind the patent office, he now focused entirely on research and teaching. This transition was a relief after years of balancing scientific ambitions with bureaucratic work. At Zurich, he continued to develop his theories, producing papers that refined his views on light and energy. It was here that he proposed the idea of wave-particle duality in more detail, arguing that light could behave as both a continuous wave and a stream of discrete particles. This paradoxical view was unsettling to many, but foreshadowed the quantum mechanics that would dominate the 20th century. Einstein's growing reputation also took him beyond Switzerland. In 1911, he accepted a professorship at the German University in Prague, where he spent a productive year. Prague offered him new colleagues, resources, and an environment that valued intellectual exchange. During this period, he published more work on radiation and relativity, continuing to build his profile in the European scientific community. Despite his achievements, he sometimes felt isolated in Prague, longing for the familiar intellectual circles of Switzerland. In 1912, he returned to Zurich, taking a position at the Polytechnic where he had once studied. His career had come full circle, from struggling student to professor, at one of the most respected institutions in Switzerland. The return also reconnected him with old friends and colleagues, renewing his sense of belonging. Recognition grew beyond academia as well. Einstein's theories began to appear in newspapers and popular science publications, where they were described in simplified terms for the general public. The idea that time and space were relative fascinated readers, even if the technical details remained beyond their grasp. Einstein's name slowly entered the broader cultural conversation, associated with innovation, daring, and the challenging of established truths. Meanwhile, his personal life became more complicated. His marriage to Mileva Maric, once strengthened by shared intellectual passion, came under strain. The responsibilities of raising two sons, combined with financial pressures and Einstein's intense focus on his work, created tension. Mileva, who had once been his close collaborator, often felt sidelined as Einstein's fame grew. Their relationship endured through these years, but the cracks widened. By 1913, Einstein was invited to Berlin to join the Prussian Academy of Sciences, one of the most prestigious institutions in Europe. The offer included freedom from teaching obligations, allowing him to focus exclusively on research. Surrounded by prominent figures, such as Max Planck, he entered a new stage of his career at the heart of German science. The move to Berlin also brought him closer to extended family, though it deepened the strains in his marriage, as Mileva struggled to adapt to the change. Einstein's reputation, by this time, was firmly established. He was no longer a marginal figure at a patent office, but a recognized leader of theoretical physics. Yet even as he gained status, he was not satisfied. His mind was fixed on a problem that had haunted him since his student years: the extension of relativity to include gravity and acceleration. Solving this problem required a new way of thinking about space, time, and matter, and he was prepared to devote the next decade to it. By the time Albert Einstein settled into his role in Berlin in 1914, he was firmly established as a major figure in European science. He had joined the Prussian Academy of Sciences, an honor reserved for the most accomplished minds of the era, and his work on special relativity had already set him apart from his contemporaries. Yet he was not content with the progress he had made. He knew that the theory of relativity, as it stood, was incomplete. Special relativity applied only to systems moving at constant velocity. It did not address acceleration, nor did it account for the most pervasive force in nature, gravity. Einstein's determination to extend relativity to cover these phenomena became the central focus of his life. The challenge was immense. Gravity had been explained for centuries by Newton's law of universal gravitation, which described it as an attractive force between masses acting across space. Newton's theory had proven extraordinarily successful, predicting the motion of planets and the behavior of objects on Earth with great precision. But when considered alongside relativity and the principles of electromagnetism, Newton's view of gravity seemed incomplete. Einstein sensed that gravity could not be understood as a simple force acting at a distance, but had to be integrated into the fabric of space and time itself. The key to his approach lay in a simple but profound idea he later called the equivalence principle. While pondering the relationship between acceleration and gravity, Einstein imagined a thought experiment. Suppose a person were in a closed room, unable to see outside. If the room were stationary on Earth, the person would feel the pull of gravity downward, but if the room were far out in space, accelerating upward at exactly 9.8 meters per second squared, the person would feel an identical force pressing them to the floor. To the occupant, the experiences would be indistinguishable. From this, Einstein concluded that acceleration and gravity were fundamentally connected. The equivalence principle became the cornerstone of his thinking. It suggested that gravity was not a mysterious force transmitted across space, but a feature of the geometry of space itself. Matter and energy, he reasoned, could curve space and time, and this curvature would guide the motion of objects. In this new vision, planets orbited the sun, not because they were pulled by an invisible force, but because the sun's mass warped the space-time around it, and the planets followed the natural paths within that curvature. Developing this idea into a full theory required mathematical tools beyond what Einstein had mastered as a student. He turned to advanced geometry, particularly the field of differential geometry, developed by Bernhard Riemann in the 19th century. These mathematical methods allowed him to describe curved surfaces and spaces, providing a language in which to express the curvature of spacetime. Einstein collaborated with his friend Marcel Grossmann, a mathematician, to help him navigate these complex techniques. The years that followed were filled with intense struggle. From 1912 onward, Einstein worked tirelessly, producing draft after draft of equations that sought to capture the relationship between matter, energy, and the curvature of space-time. At times he believed he had solved the problem, only to discover inconsistencies or errors that forced him to start over. The process consumed him, demanding his full concentration. He once described the effort as some of the most exhausting work of his life. Meanwhile, the world around him was entering turmoil. In 1914, as Einstein moved to Berlin, Europe descended into the First World War. Nationalism, militarism, and political tensions reshaped daily life. Einstein, who opposed war and distrusted nationalism, felt increasingly isolated in a society swept up by patriotic fervor. Many of his colleagues signed public declarations supporting Germany's war aims, but Einstein refused. He joined a small minority of intellectuals who spoke out for peace, a position that made him both admired and criticized. Amid this political upheaval, his personal life unraveled. His marriage to Mileva Maric had been strained for years, and the move to Berlin worsened their difficulties. Mileva struggled with life in the new city, and their disagreements deepened. In 1914, they separated, with Mileva returning to Switzerland with their 2 sons. The marriage never recovered, and divorce followed a few years later. The emotional toll weighed heavily on Einstein, yet he remained absorbed in his scientific quest. Despite personal and political pressures, his progress on relativity advanced. By 1915, after years of trial and error, Einstein finally derived the field equations of general relativity. These equations described how matter and energy determined the curvature of spacetime, and how that curvature dictated the motion of matter. It was a radically new understanding of gravity, replacing Newton's action at a distance with a dynamic interplay between geometry and physics. Einstein presented the completed theory in a series of lectures in Berlin in November 1915. The reception among physicists was mixed at first. The mathematics was challenging, and the implications were profound. But one prediction captured immediate attention. The theory suggested that light would bend when passing near a massive body, such as the Sun, due to the curvature of spacetime. This was a testable effect, something that could confirm or challenge the theory. The outbreak of war, however, made experimental verification difficult. Astronomers would need to observe starlight passing near the Sun during a solar eclipse, when the stars would be visible close to the Sun's edge. Plans for such expeditions were delayed by the conflict. Still, the theoretical framework was in place, and Einstein's achievement marked one of the greatest milestones in the history of science. General relativity represented not just a new theory, but a new way of thinking about the universe. Space and time were no longer passive backgrounds in which events unfolded. They were active, dynamic entities shaped by the presence of matter and energy. The universe itself was flexible, curved, and interconnected in ways that few had imagined. The years immediately after the theory's publication would determine whether it stood the test of experiment. For Einstein, the struggle to develop general relativity had consumed nearly a decade of his life. But the true test lay ahead. Would nature confirm his bold vision of curved spacetime? After completing the general theory of relativity in 1915, Albert Einstein had provided the scientific world with a bold new description of gravity. Instead of a force acting instantaneously across empty space, gravity was the result of the curvature of spacetime caused by mass and energy. Objects moved not because they were pulled, but because they followed the natural paths within this curved geometry. The theory was elegant and mathematically consistent. But in science, beauty alone is not enough. A theory must withstand the test of observation. One of the clearest predictions of general relativity was that light would bend when it passed near a massive body, such as the Sun. Newton's theory had also allowed for some bending, treating light as particles influenced by gravitational attraction, but Einstein's prediction was nearly twice as large. This difference created an opportunity. If starlight passing close to the Sun could be measured during a solar eclipse, astronomers would have a way to determine whether Einstein's vision of curved spacetime was correct. The First World War, however, delayed efforts to conduct such an experiment. International collaboration in science became difficult, and expeditions were postponed. Einstein himself endured the war years in Berlin with a mixture of isolation and quiet determination. While colleagues and acquaintances were swept up in patriotic enthusiasm, he remained opposed to nationalism and war, a position that made him a target of criticism in some circles. Despite these tensions, he continued refining his theory, confident that one day it would be tested. By 1919, the war had ended, and opportunities for scientific collaboration reopened. In Britain, the astronomer Sir Frank Watson Dyson proposed organizing expeditions to observe the solar eclipse of May 29. Two teams were assembled, one led by Arthur Eddington, the director of the Cambridge Observatory, who would travel to the island of Principe off the coast of West Africa, and another led by Andrew Claude de la Charrois Crumelin, who would set up in Sobral, Brazil. The goal was to photograph stars positioned near the sun during the eclipse and measure how much their apparent positions shifted. Eddington, a Quaker who had opposed the war and was deeply committed to reconciliation, saw in this project not only a scientific opportunity, but also a symbolic act of rebuilding international cooperation. Testing the theory of a German scientist with the support of British astronomers so soon after the conflict carried significance beyond physics. The eclipse itself was challenging to observe. Clouds threatened to obscure the view, and the equipment was delicate. At Principe, Eddington battled poor weather, but managed to capture a small number of usable photographic plates. In Sobral, the Brazilian team obtained clearer images. The analysis of these photographs required painstaking measurements, comparing the apparent positions of stars during the eclipse with their positions at other times. When the results were announced later in 1919, they confirmed Einstein's prediction. The bending of light matched the value given by general relativity, rather than the smaller one predicted by Newtonian physics. The confirmation electrified the scientific world. For the first time, a dramatic and visible effect in the heavens had validated Einstein's revolutionary theory. The impact extended far beyond the scientific community. Newspapers across Europe and America reported the news with dramatic headlines. Einstein was suddenly transformed from a respected physicist into an international celebrity. Articles described him as the successor to Newton, a genius who had redefined the very structure of the universe. Photographs of his distinctive face, with its unruly hair and thoughtful expression, became widely circulated. For the general public, the discovery that time and space could bend was both bewildering and fascinating. Though few understood the mathematics, the idea captured the imagination. In an era still recovering from the destruction of the war, Einstein's success was presented as a triumph of human intellect and cooperation. Einstein himself was both pleased and cautious. He welcomed the confirmation of his theory, but remained aware that science advanced through ongoing tests and refinement. He famously remarked, when asked what he would have thought if the eclipse had contradicted his theory, that he would have been sorry for the good Lord because the theory was correct. Such confidence reflected his deep belief in the logical necessity of relativity. The eclipse of 1919 marked the beginning of Einstein's fame as a public figure. Invitations poured in from universities and institutions across the world. He traveled to give lectures, met political leaders and intellectuals, and became a symbol of scientific genius in popular culture. His rise to fame coincided with a period of political instability in Germany, where inflation and unrest shaped daily life. Yet Einstein seemed to rise above these difficulties as a figure admired internationally. The confirmation of general relativity also solidified Einstein's place at the center of 20th century physics. While other scientists contributed enormously to the emerging fields of quantum mechanics and nuclear theory, none captured the imagination of the world as he did. Relativity was more than a technical achievement. It was a new way of conceiving the universe, and Einstein had become its author. The public announcement of the eclipse results in late 1919 propelled Albert Einstein into a position few scientists had ever occupied. Overnight, he was transformed from a respected physicist within academic circles to a figure known across the world. Newspapers described him as the new Newton, a thinker who had overturned centuries of established knowledge Headlines framed his theory in dramatic terms, declaring that space and time themselves had been altered. For the general public, the story was irresistible. Einstein's appearance added to his growing legend. With his untamed hair, expressive eyes, and modest demeanor, he embodied the popular image of the eccentric genius. Photographs of him were printed in newspapers and magazines, and his name quickly became synonymous with scientific brilliance. The contrast between his modest lifestyle and the grandeur of his discoveries only added to his appeal. He lived simply, spoke plainly, and often resisted the pomp that accompanied his fame. Yet he was thrust into a role as one of the most recognizable people of his generation. The years immediately following the eclipse were filled with travel and recognition. Einstein was invited to universities across Europe to lecture on relativity. His presentations often drew audiences far beyond the usual academic crowd, with politicians, artists, and ordinary citizens eager to hear him speak. Though many could not follow the mathematics, they were fascinated by the implications of a universe where time could slow down and light could bend. In 1921, Einstein undertook a major journey to the United States. He was welcomed with enthusiasm, greeted by crowds, reporters, and dignitaries. American newspapers covered his visit extensively, presenting him as both a scientific genius and a cultural phenomenon. His lectures were attended by thousands, and his presence was treated almost like that of a visiting statesman. The trip was not only about science. Einstein also used it to support the cause of the Hebrew University in Jerusalem, which he championed as part of his commitment to Jewish cultural and educational renewal. While relativity dominated the headlines, Einstein's Nobel Prize in Physics, awarded in 1921, was not for that theory, but for his work on the photoelectric effect. The decision reflected the caution of the Nobel Committee, which regarded relativity as still too controversial at the time. Yet the award only added to his stature, reinforcing the sense that he was a central figure in modern science. As his fame spread, Einstein became more than a scientist. He was increasingly viewed as a public intellectual, someone whose opinions on a wide range of topics carried weight. He spoke openly about politics, philosophy, and social issues, often challenging conventional views. His opposition to militarism and nationalism, sharpened during the First World War, remained strong. He advocated for peace and international cooperation, aligning himself with movements that sought to reduce the possibility of future wars. His outspokenness attracted both admiration and criticism, but he did not shy away from taking moral positions. In Germany, Einstein's growing prominence came during a period of great political instability. The country was struggling with the consequences of the war, including severe economic hardship, political violence, and social unrest. Einstein's advocacy for democracy and peace, along with his Jewish background, made him a target for nationalist groups. He received hostile letters and threats, yet he continued to speak out, believing that scientists had a responsibility to engage with the world beyond their laboratories. Despite these pressures, he remained deeply engaged in his scientific work. During the 1920s, he continued to refine general relativity, explored unified field theories that sought to connect gravity with electromagnetism, and contributed to debates about the emerging field of quantum mechanics. His insistence on the need for conceptual clarity, even when it put him at odds with younger physicists, showed his dedication to the principles of reason and consistency. Einstein's role as a global figure also meant that his personal life was increasingly under public scrutiny. His divorce from Mileva Maric had been finalized in 1919, and shortly afterward, he married Elsa Lowenthal, his cousin, who provided companionship and support as he navigated the demands of fame. Together, they managed the stream of invitations, interviews, and obligations that filled his days. Elsa often served as his organizer and protector, ensuring that he could focus on science while also meeting his public responsibilities. By the mid-1920s, Einstein was firmly established as one of the most famous people in the world. His face appeared on magazine covers, his lectures filled halls, and his theories became part of popular culture. The word relativity entered everyday language, often misunderstood, but always associated with profound change. For many, Einstein symbolized the power of human thought to unlock the mysteries of the universe. This fame, however, carried burdens. The constant attention sometimes wearied him, and he longed for quiet moments to think and write. Still, he recognized that his position gave him a platform to advocate for causes he believed in, from scientific collaboration to social justice. His life had become a blend of private inquiry and public responsibility, and he balanced the two as best he could in an era of rapid change. During the 1920s, Albert Einstein stood at the center of both admiration and controversy. His theory of general relativity had secured his place as one of the foremost scientists in history, and his public reputation as a genius had spread across the globe. Yet within physics, a new movement was taking shape that unsettled him. The emerging field of quantum mechanics promised to explain the behavior of atoms and subatomic particles, areas where relativity alone could not provide answers. While Einstein had played a role in its early development through his work on the photoelectric effect, he grew increasingly skeptical of the direction the theory was taking. Quantum mechanics arose from attempts to understand phenomena that classical physics could not explain, such as the emission of light from heated objects, the stability of atoms, and the strange patterns observed in experiments with electrons and photons. Physicists like Niels Bohr, Werner Heisenberg, and Erwin Schrödinger developed mathematical frameworks that accurately described these behaviors. Their equations produced results that matched experiments with astonishing precision. Yet the interpretation of these equations suggested a universe governed by probabilities rather than certainties, randomness rather than strict causality. Einstein resisted this shift. For him, science was about uncovering the underlying laws of nature, rules that determined events with clarity. The suggestion that fundamental processes were indeterminate struck him as incomplete, a sign that quantum mechanics, though powerful, was not the final word. He acknowledged the success of the theory in predicting outcomes, but he doubted that it captured the deeper reality beneath appearances. The debates between Einstein and Bohr became legendary. At scientific conferences, particularly the series of Solvay conferences in Brussels, the two men engaged in extended discussions. Bohr defended the probabilistic nature of quantum mechanics, arguing that uncertainty was not a flaw, but a fundamental feature of nature. Einstein countered with thought experiments designed to expose what he saw as weaknesses in the theory. He sought to show that quantum mechanics could not be a complete description of reality. One of Einstein's most famous objections was expressed in the phrase, "God does not play dice." With this statement, he conveyed his refusal to accept that chance lay at the heart of physical law. For him, the universe was orderly, governed by principles that might be hidden but could, in time, be discovered. His insistence on determinism placed him increasingly at odds with the younger generation of physicists, who embraced the probabilistic approach. Despite his skepticism, Einstein continued to make contributions to quantum theory. He introduced concepts that shaped later developments, such as the idea of entanglement, where particles could remain connected across vast distances. Though he initially described entanglement as evidence of the incompleteness of quantum mechanics, it became a central feature of the field, influencing later discoveries in quantum information and computing. The debates between Einstein and Bohr were not hostile in spirit. Both men respected each other deeply, and their exchanges were marked by intellectual rigor rather than personal animosity. Yet the disagreements reflected a genuine divide in the philosophy of science. Einstein valued clarity, determinism, and underlying order, while Bohr emphasized the limits of knowledge and the necessity of embracing probability. Outside of these debates, Einstein's life in the 1920s remained active and varied. He continued to refine his work on unified field theories, an ambitious attempt to connect all the forces of nature into a single framework. Though these efforts did not succeed, they reflected his lifelong desire for coherence and scientific understanding. His role as a public figure also expanded. He traveled widely, delivering lectures in Europe, the United States, and Asia. In Japan, he was welcomed with extraordinary enthusiasm, and his lectures attracted large audiences. He became not only a scientist, but also a cultural ambassador, representing the potential of human intellect and international cooperation. His fame carried symbolic weight in a world still recovering from the devastation of the First World War. At the same time, Einstein's outspoken views on politics and society continued to draw attention. He advocated for pacifism, internationalism, and the rights of minorities, speaking out against racism and injustice. His Jewish heritage also became increasingly central to his public role. As anti-Semitism grew more visible in Germany and elsewhere, Einstein supported the Zionist movement, lending his name and influence to the creation of institutions such as the Hebrew University of Jerusalem. He saw education as a vital tool for cultural renewal and social progress. The 1920s were thus a period of both scientific and social engagement. Einstein was not isolated in his study, but active in the world, grappling with ideas that challenged his deepest convictions, while also addressing the pressing issues of his time. His debates over quantum mechanics demonstrated his refusal to accept easy answers, and his public advocacy showed his commitment to the broader responsibilities of intellectual life. As the 1920s gave way to the 1930s, Albert Einstein's life took a dramatic turn. His fame as a scientist had already reached global proportions, and his public voice was widely respected. Yet the political environment in Germany, where he lived and worked, was becoming increasingly hostile. The rise of extremist movements, fueled by economic hardship and resentment after the First World War, created an atmosphere in which Einstein's identity, beliefs, and outspokenness made him a target. Germany, in the late 1920s, was marked by instability. The Weimar Republic struggled with inflation, unemployment, and political divisions. Extremist groups gained influence by exploiting anger and fear. Nationalist and anti-Semitic rhetoric became louder, and violence in the streets grew more common. For Einstein, a Jewish intellectual who publicly supported democracy, international cooperation, and pacifism, the situation became dangerous. Einstein did not remain silent. He used his platform to denounce militarism and nationalism, calling for peace and mutual understanding between nations. His willingness to speak openly made him a prominent target for criticism. Newspapers aligned with nationalist groups accused him of undermining German pride and tradition. Anti-Semitic pamphlets singled him out as an example of Jewish influence in science and culture, attacking both his person and his theories. At the same time, Einstein remained deeply involved in scientific work and international collaboration. He continued to travel widely, giving lectures abroad and participating in global efforts to promote peace. In 1930, he visited the United States again, where he was welcomed warmly by universities and Jewish organizations. His visits highlighted the contrast between the admiration he received abroad and the hostility he increasingly faced at home. By 1932, the situation in Germany had grown dire. The Nazi Party, led by Adolf Hitler, was gaining momentum. Their ideology combined radical nationalism with virulent anti-Semitism, and Einstein's prominence made him a symbolic target. As the Nazis rose to power, they denounced his theory of relativity as Jewish physics, contrasting it with what they called Aryan science. They sought to discredit his work, not on scientific grounds, but on racial and political ones. Einstein could see the danger clearly. In early 1933, he traveled once again to the United States, planning a series of lectures and meetings. While he was abroad, Hitler became Chancellor of Germany, and the Nazis began consolidating power. Einstein quickly realized that returning home would be impossible. His apartment in Berlin was raided, his property was confiscated, and right-wing newspapers declared him an enemy of the German nation. A photograph of him was even published in one publication under the headline, "Not Yet Hanged." The decision to leave Germany permanently was both painful and inevitable. Einstein resigned from the Prussian Academy of Sciences and gave up his German citizenship. For a man who had spent much of his life in German-speaking academic circles, it was a profound break. Yet he recognized that his future, both personally and professionally, could no longer be tied to a country descending into dictatorship. Einstein accepted an offer from the Institute for Advanced Study in Princeton, New Jersey, a newly founded institution that sought to provide scholars with the freedom to pursue research without teaching obligations. The position offered stability and security at a time when both were urgently needed. In October 1933, he sailed for the United States with his wife Elsa, settling in Princeton, where he would remain for the rest of his life. The move to America was more than a change of residence. It symbolized Einstein's transformation from a European intellectual into a global figure whose voice carried weight across continents. He had become not only a scientist, but also a symbol of resistance to tyranny and a representative of the many intellectuals and artists forced to flee Nazi oppression. His story was part of a broader tragedy in which countless lives were uprooted, yet his prominence allowed him to adapt more easily than most. Even as he settled into Princeton, Einstein maintained a deep concern for the fate of those left behind. He used his influence to help other Jewish scientists and intellectuals find refuge abroad, writing letters of recommendation and lobbying institutions to provide positions for displaced scholars. His home in Princeton became a point of contact for many who sought safety. Einstein's emigration also marked a shift in his scientific and political roles. In Princeton, he continued to pursue theoretical research, focusing on attempts to unify the forces of nature. At the same time, he became increasingly engaged in public debates about war, peace, and the responsibilities of science in a changing world. The rise of fascism and the looming threat of another global conflict pressed heavily on his mind, shaping the choices he would make in the years ahead. When Albert Einstein arrived in the United States in 1933, he carried with him both relief at escaping Nazi Germany and uncertainty about his future in a new land. The Institute for Advanced Study in Princeton, New Jersey, offered him a permanent home, free from the teaching duties and administrative burdens that often consumed academics. The Institute's mission was to provide leading scholars with the freedom to think and create without distraction, and Einstein's appointment symbolized the ambition of the new institution. Princeton was a quiet town, far removed from the political storms of Europe. Einstein and his wife Elsa settled into a modest house on Mercer Street, where he would live for the remainder of his life. The home became a place of both refuge and curiosity. Neighbors often saw him walking through town in his rumpled clothes and worn shoes, carrying papers under his arm, seemingly lost in thought. He declined many of the trappings of fame, preferring a simple routine and a life centered on ideas rather than appearances. At the Institute, Einstein worked alongside a select group of scholars, including mathematicians and physicists drawn from across the world. The atmosphere was deliberately quiet and contemplative, designed to foster deep concentration. Einstein's focus turned toward unification, the attempt to create a single theory that would bring together gravity and electromagnetism. He believed that the elegance of nature required such a unified framework, and he devoted countless hours to this pursuit. Though these efforts did not yield the breakthrough he hoped for, they reflected his commitment to coherence and order in scientific understanding. Life in Princeton also gave Einstein a new role as a mentor and public figure. Young scientists and visitors sought him out, eager to hear his thoughts or simply to be in his presence. His office at the Institute became a place where ideas flowed, though he often resisted the role of teacher in a formal sense. He preferred informal conversations, walking with colleagues, and discussing problems in an unstructured way. His openness and lack of pretension endeared him to many. Even as he immersed himself in research, the world outside pressed heavily on him. The rise of fascism in Europe, the persecution of Jews, and the growing threat of war demanded his attention. Einstein received countless letters from colleagues and strangers, seeking help to escape Germany and find refuge abroad. He responded with empathy and practical assistance, using his reputation to secure positions for scientists at universities in the United States and Britain. For many, his support meant the difference between survival and persecution. His political voice also grew louder in these years. Einstein, long a pacifist, had preached against war throughout the 1920s. Yet the brutality of the Nazi regime forced him to reconsider aspects of his stance. He recognized that the threat posed by Hitler could not be met with words alone. His commitment to peace did not waver, but he began to argue that resistance to fascism, even by force, was necessary. This shift was difficult for him, but it reflected his willingness to adapt moral convictions to the harsh realities of history. Einstein's presence in the United States quickly became more than academic. He was a public figure whose words carried weight on issues far beyond physics. Journalists sought his opinions, and his name appeared regularly in newspapers. He spoke out against anti-Semitism, racism, and the dangers of dictatorship. He supported civil rights causes, identifying parallels between the persecution of Jews in Europe and the struggles of African Americans in the United States. His moral authority gave his words resonance, even when they stirred controversy. Within the scientific community, Einstein's theories continued to influence research. General relativity inspired astronomers and cosmologists to reconsider the structure of the universe, while his early work on quantum theory continued to shape debates in physics. Though he remained skeptical of quantum mechanics in its dominant form, his challenges pushed others to refine their arguments and experiments. His insistence on clarity and coherence served as a counterbalance to approaches that embraced uncertainty without deeper explanation. Daily life in Princeton remained simple despite his fame. Einstein enjoyed sailing on nearby lakes, often in small boats that he handled with a mix of enthusiasm and absent-mindedness. He played the violin regularly, finding in music a source of relaxation and inspiration. Visitors were often struck by the contrast between the monumental impact of his ideas and the modesty of his lifestyle. He seemed uninterested in wealth or luxury, preferring the company of friends and the pursuit of thought. The quiet rhythm of Princeton life was increasingly interrupted by the march of events in Europe. By the late 1930s, Germany's aggression had spread, and the prospect of another world war loomed. Reports of persecution and violence against Jews grew ever more horrific. Einstein, though safe in America, felt a deep responsibility toward those in danger and a rising anxiety about the course of world affairs. His personal world also changed during these years. Elsa, his wife, fell ill and died in 1936 after a period of declining health. Her death left him saddened, but also more solitary, surrounded by friends and colleagues, but without the domestic partnership that had sustained him since the difficult years in Berlin. He continued to live at Mercer Street, maintaining his routine and focusing on his work, but his personal life was marked by quiet endurance rather than companionship. As the 1930s drew to a close, Einstein's role as both scientist and public figure placed him at the center of critical developments. His theories had transformed physics, his voice carried moral weight, and his presence in the United States symbolized the displacement of intellectual life from a Europe descending into tyranny. The coming war would test his convictions further, and his decisions would connect him to one of the most consequential projects in human history. As the 1930s turned into the 1940s, the world stood on the edge of another great conflict. Albert Einstein, by then firmly established at Princeton, watched events in Europe with a mix of sorrow and urgency. The rise of Nazi power had already forced him into exile, and the regime's persecution of Jews, scientists, and intellectuals convinced him that the world faced a danger, unlike any it had seen before. Though he lived in safety in the United States, he could not escape the knowledge that friends, colleagues, and countless others remained trapped in Germany and occupied territories. The scientific community was also changing rapidly. Discoveries in nuclear physics revealed new possibilities for harnessing the energy locked within atoms. In 1938, German physicists Otto Hahn and Fritz Strassmann demonstrated nuclear fission, showing that splitting the nucleus of uranium released tremendous amounts of energy. The implications were immediately clear to physicists. This process could, in principle, be used to create a weapon of unprecedented power. The idea of a bomb, powered by atomic fission, spread quickly among scientists, raising both fascination and dread. Einstein was not directly involved in the research on nuclear fission. His focus remained on theoretical physics, particularly his attempts to unify the forces of nature. But his fame and his earlier work on mass energy equivalence, expressed in the equation E equals mc squared, meant that his name became linked in the public mind to the concept of atomic energy. In reality, the path from theoretical equation to practical weapon depended on a vast amount of experimental and engineering work that Einstein himself did not undertake. Still, he recognized the danger posed if Nazi Germany were the first to develop such a weapon. In 1939, concerned colleagues approached Einstein to lend his support to efforts to alert the United States government. Hungarian physicist Leo Szilard, along with Edward Teller and Eugene Wigner, recognized that uranium fission could be used to create an immensely destructive bomb. They also knew that Germany had capable scientists and access to resources that might allow them to pursue such a project. Szilard drafted a letter to President Franklin D. Roosevelt, warning of the potential for nuclear weapons and urging the United States to accelerate research in this area. Einstein, with his international reputation and moral authority, was asked to sign the letter. Though deeply uneasy about becoming involved in military matters, he agreed, convinced that the threat of a Nazi atomic bomb was too great to ignore. The letter, delivered to Roosevelt in October 1939, outlined the possibility of a chain reaction in uranium and the enormous energy it could release. It urged the government to take steps to secure uranium supplies and support further research. This letter is often remembered as Einstein's connection to the creation of the atomic bomb. In truth, his involvement ended there. He played no role in the Manhattan Project, the massive U.S. program that eventually developed the bomb. In fact, because of his outspoken political views and associations with pacifist and left-leaning causes, Einstein was considered a security risk and deliberately excluded from the project. Still, his signature on the 1939 letter symbolized his reluctant acknowledgement that in extraordinary circumstances, scientific knowledge could not remain separate from political and military realities. As war erupted in Europe and spread across the world, Einstein continued his life in Princeton, working on his unified field theories and supporting causes close to his heart. He helped raise funds for Jewish refugees and advocated for the rescue of scholars trapped in Europe. His house on Mercer Street became a place where displaced intellectuals found assistance and encouragement. His empathy and moral concern reached far beyond the scientific community, reflecting his belief that knowledge carried responsibility. The war years also saw Einstein reflect deeply on the role of science in society. He understood that discoveries made in the spirit of curiosity could be turned into tools of destruction. The tension between the pursuit of knowledge and the uses to which it might be put troubled him, yet he did not retreat from his conviction that understanding nature was a noble endeavor. Instead, he emphasized the importance of guiding scientific progress with ethical reflection and social responsibility. By the time the United States entered the war in 1941, Einstein was well into his 60s. He followed events with concern, particularly the news of Nazi aggression and the horrors inflicted on Jewish communities across Europe. He lent his voice to appeals for aid and spoke publicly about the dangers of tyranny. His personal life remained quiet and disciplined, structured around his work, his violin, and his walks through Princeton. Yet the shadow of the conflict touched every aspect of his thinking. The culmination of the wartime nuclear effort came in 1945, when the United States dropped atomic bombs on Hiroshima and Nagasaki. Einstein was not involved in the project, but when news of the destruction reached him, he was profoundly shaken. He later expressed regret for signing the 1939 letter, believing that he had indirectly contributed to the development of weapons of mass destruction. At the same time, he insisted that the responsibility for their use lay with political leaders, not with scientists who had sought only to warn of dangers. The atomic age had arrived, and Einstein's role in it, however limited, made him a central figure in the public imagination. His famous equation became the symbol of nuclear energy, even though he had not built the bomb. The events of 1945 reinforced his determination to advocate for peace, international cooperation, and control of nuclear weapons, causes that would dominate the final years of his life. The end of the Second World War marked a profound turning point for Albert Einstein. The devastation of Hiroshima and Nagasaki in August 1945 revealed the destructive power of atomic weapons, and Einstein's name, tied in the public imagination to the famous equation E equals mc squared, was linked immediately to the dawn of the nuclear age. Though he had played no role in the Manhattan Project and had not worked on the design of nuclear weapons, the association was unavoidable. Einstein felt a deep responsibility to address the consequences of this new reality. Privately, he was shaken by the destruction. He later admitted regret for signing the 1939 letter to President Roosevelt that had urged investigation into uranium research, even though he knew the letter had only been a small factor in the development of the bomb. To friends and colleagues, he emphasized that scientific discoveries themselves were not inherently evil, but the uses to which they were put required wisdom and restraint. For Einstein, the atomic bomb highlighted the need for humanity to create new political and ethical structures capable of managing the dangers of advanced technology. In the months after the war, Einstein became one of the most prominent voices calling for international control of nuclear weapons. He joined organizations that sought to raise awareness of the risks posed by the nuclear arms race, including the Emergency Committee of Atomic Scientists, which he helped found in 1946. The committee sought to educate the public about nuclear dangers and advocate for a system of global governance that could prevent war. Einstein believed that only by creating strong international institutions could humanity avoid self-destruction. He wrote articles, gave interviews, and signed open letters urging governments to abandon secrecy and cooperate on atomic energy. His appeal was not only scientific, but also moral. He argued that the survival of civilization required transcending national rivalries and embracing a new form of political organization that placed the interests of humanity above those of individual nations. In this period, Einstein's identity as a scientist merged with his role as a public intellectual and moral leader. His pacifist convictions, however, were not absolute in the face of tyranny. He continued to defend his earlier shift during the war, when he had abandoned strict pacifism to support resistance against Nazi aggression. To him, that was a tragic necessity. But in the post-war world, he insisted, the path forward must be peace. The atomic bomb had made traditional war obsolete. Any future conflict among great powers risked annihilation. Einstein's advocacy for global governance was met with mixed responses. Some admired his vision, seeing in it a necessary response to the dangers of the nuclear age. Others criticized him as naive or unrealistic, arguing that nations would never surrender sovereignty to a supranational authority. Still, his willingness to speak boldly ensured that the debate about nuclear weapons was never confined to politicians and generals alone. At the same time, Einstein continued his work in theoretical physics. He remained focused on unified field theory, seeking a framework that would reconcile gravity and electromagnetism. These efforts consumed much of his time at Princeton, though they did not yield the breakthrough he sought. Younger physicists were increasingly drawn to quantum mechanics and the rapidly advancing field of particle physics, leaving Einstein somewhat isolated in his insistence on a more complete and deterministic vision of nature. Despite this divergence, he persisted, driven by conviction that the universe's laws must be unified. In public life, Einstein expanded his involvement in social causes beyond nuclear issues. He spoke against racism in the United States, supporting civil rights leaders and condemning segregation as a form of injustice. He corresponded with activists, lent his name to campaigns, and used his fame to amplify voices that might otherwise have been ignored. His comparison of anti-Semitism in Europe with racism in America reflected his belief in universal human dignity and his refusal to remain silent in the face of discrimination. Einstein's Jewish identity also shaped his post-war commitments. He supported the creation of the State of Israel, though he did so cautiously, emphasizing the importance of coexistence and cooperation with Arab neighbors. He advocated for the cultural and educational development of the Jewish community, continuing his long support for the Hebrew University of Jerusalem. Yet he also warned against nationalism of any kind, fearing that it could repeat the mistakes he had seen destroy Europe. His vision was always internationalist, grounded in a belief that humanity shared a common destiny. Daily life in Princeton remained consistent with his character. He walked to the institute, played his violin, and welcomed a steady stream of visitors, from world leaders to young students. His modest home on Mercer Street became a place where conversations about science, politics, and philosophy intertwined. Despite his fame, he retained a disarming simplicity, uninterested in wealth or formalities. By the late 1940s, Einstein was both a scientific elder and a moral conscience for the nuclear age. He understood the power of his voice, and he used it to press for peace and justice. Though not all agreed with his proposals, few could ignore his authority. His warnings about the dangers of nuclear weapons proved prescient as the Cold War began and the United States and the Soviet Union entered an arms race. The balance of his life in this period reflected the two great themes that had always driven him: the search for understanding in science and the search for humanity's survival through peace. In both realms, he pursued clarity, coherence, and honesty, refusing to compromise his convictions, even when they placed him in opposition to prevailing views. In the years immediately following the Second World War, Albert Einstein found himself caught in the shifting political currents of the early Cold War. The United States, once an ally of the Soviet Union against Nazi Germany, now entered a period of deep suspicion and rivalry with its former partner. This rivalry fueled a nuclear arms race and also created an atmosphere of fear within American society. Einstein, already an outspoken advocate for peace and international cooperation, refused to remain silent as new political pressures grew around him. His reputation as the world's most famous scientist gave weight to his words, but it also meant that his views were scrutinized more closely than those of most intellectuals. Einstein continued to argue that nuclear weapons posed an existential threat to humanity. He urged governments to pursue disarmament and to establish strong international institutions capable of managing conflicts peacefully. These ideas clashed with the rising climate of suspicion in the United States, where loyalty tests, investigations, and accusations of communist sympathies dominated public discourse. The late 1940s and early 1950s in America were marked by McCarthyism, named after Senator Joseph McCarthy, who led aggressive investigations into alleged communist influence in government, education, and the arts. Intellectuals, scientists, and artists often came under suspicion simply for expressing left-leaning views or for having associated with progressive causes. Einstein, who had long supported socialist ideas and had been active in organizations advocating peace and equality, was not immune from these suspicions. Rather than retreat, he chose to confront the atmosphere of fear directly. In public statements, he criticized McCarthyism as a betrayal of democratic principles. He argued that freedom of thought was essential for both science and society, and that silencing dissent through intimidation would damage the very foundations of American life. His position was courageous, for speaking out during this period carried real risks, but Einstein believed that silence would amount to complicity. Einstein's critique of McCarthyism was part of a broader philosophy he had developed over decades. He believed that intellectuals had a duty to speak truth to power, regardless of the consequences. He understood that science and politics could not be entirely separated, especially in an age when scientific discoveries had such direct impact on warfare and international relations. For him, moral responsibility was inseparable from intellectual achievement. His political involvement during the early Cold War years also extended to international issues. He supported movements for world government, seeing in them a possible framework for avoiding future wars. The idea of creating a supranational authority with the power to regulate nuclear weapons and mediate disputes appealed to him, though many considered it unrealistic. Still, Einstein lent his name to petitions and open letters, believing that even if the goal seemed distant, it was necessary to point humanity in that direction. In addition to his criticism of American political repression, Einstein continued to address issues of racial inequality in the United States. He accepted invitations to speak at historically black colleges, publicly condemned segregation, and maintained friendships with African American leaders. He drew explicit comparisons between racism in America and anti-Semitism in Europe, insisting that prejudice of any kind was a moral failing that weakened society. His voice added moral weight to the growing civil rights movement, and he used his fame to bring attention to injustices often ignored by mainstream institutions. Despite his political outspokenness, Einstein did not neglect his scientific work. At the Institute for Advanced Study, he persisted in his pursuit of a unified field theory. By this time, however, most younger physicists had shifted their focus to quantum mechanics, nuclear physics, and the emerging study of elementary particles. Einstein's refusal to accept the probabilistic nature of quantum theory left him increasingly isolated in the scientific community. Some colleagues admired his persistence, while others regarded his efforts as quixotic. For Einstein himself, the pursuit was less about immediate results and more about fidelity to his vision of a universe governed by order and harmony. Einstein's daily routine in Princeton during these years reflected his balance of public engagement and private contemplation. He remained approachable to students and colleagues, often strolling through town or sailing on local lakes. His violin continued to provide him comfort, and he cherished informal gatherings with friends. His modest home remained a place of welcome, where visitors encountered not the aloof genius of legend, but a warm and thoughtful man, often amused by the trappings of his fame. As the Cold War deepened, Einstein's warnings about nuclear weapons grew more urgent. He saw in the arms race a peril that threatened not just individual nations, but the survival of civilization itself. He feared that without bold steps toward cooperation, humanity would eventually face annihilation. Though some dismissed his calls as idealistic, others recognized that his voice, grounded in both science and conscience, carried a truth that could not be ignored. By the early 1950s, Einstein was approaching the final years of his life, but his influence as a moral authority was stronger than ever. He continued to write, speak, and advocate, aware that the world listened, not only because of his scientific achievements, but also because of the clarity of his ethical vision. In the last years of his life, Albert Einstein remained at the Institute for Advanced Study in Princeton, pursuing the great unfinished task that had occupied him for decades, the search for a unified field theory. His goal was to develop a single framework that could explain both gravitation and electromagnetism, two forces that had been described separately, but that Einstein believed must ultimately be aspects of a deeper unity. The quest reflected his lifelong conviction that nature operated according to clear, consistent principles, and that the apparent divisions observed by scientists were signs of an incomplete understanding. Einstein's efforts in this area dated back to the 1920s, but in Princeton, he devoted nearly all of his energy to the problem. He published papers and corresponded with colleagues, constantly revising his mathematical formulations. Yet as the years passed, the gap between his work and the mainstream of physics widened. Younger scientists were captivated by quantum mechanics, and later by the development of quantum field theory and particle physics. They were discovering new particles, probing the structure of the atomic nucleus, and laying the foundations of what would become the standard model of physics. Einstein remained skeptical of these directions. He did not reject the results of quantum mechanics. He acknowledged its remarkable accuracy in describing atomic phenomena, but he resisted its philosophical implications. The idea that the universe was fundamentally probabilistic, that events could occur without precise cause, remained unacceptable to him. He believed that quantum mechanics was incomplete, a powerful but partial description of reality that would eventually be subsumed within a more deterministic theory. His insistence on pursuing unification, even as the rest of the field moved elsewhere, left him increasingly isolated. Some of his contemporaries admired his determination and intellectual courage, while others regarded him as out of step with the times. Still, Einstein did not waver. For him, the pursuit of truth was not measured by popularity or consensus, but by fidelity to reason. He once remarked that even if the whole world accepted quantum mechanics as complete, he would remain convinced that it was not. Einstein's life in Princeton was marked by a quiet routine. He lived simply, walking to the institute each day, exchanging ideas with colleagues, and returning home to read, play his violin, or entertain visitors. His house on Mercer Street was modest and unpretentious, filled with books, papers, and the instruments of daily thought. He welcomed guests warmly, whether they were fellow scientists, students, or public figures. Many visitors remarked on the contrast between his extraordinary fame and his unassuming manner. As his health declined with age, Einstein continued to work with the same determination that had driven him throughout his life. He filled notebooks with equations, searching for patterns that might reveal the unity he sought. Even when hospitalized near the end of his life, he asked for his notes and continued scribbling calculations, unwilling to abandon the quest. To him, the search for understanding was not merely a profession, but the central purpose of existence. Einstein's final scientific pursuit did not yield the results he had hoped for. He did not succeed in formulating a unified field theory that satisfied his criteria for completeness and elegance. The mathematics he employed, though ingenious, did not align with the discoveries emerging from particle physics. In this sense, his last great project ended in frustration. Yet his persistence left a powerful legacy. He demonstrated that science was not only about solving immediate problems, but also about maintaining a vision of coherence and beauty, even when the path was uncertain. Beyond science, Einstein continued to engage with social and political issues. He lent his name to petitions, gave interviews on matters of war and peace, and corresponded with world leaders. His opposition to nuclear weapons remained steadfast. He argued that the survival of humanity required international cooperation, and warned that the arms race could end in catastrophe. His moral authority ensured that his words were heard, even when political leaders disagreed or dismissed them. In his later years, Einstein also reflected more deeply on philosophy and human existence. He spoke often of the importance of humility before the mysteries of the universe, of the need for compassion in human affairs, and of the limits of human understanding. He saw science and spirituality not as opposites, but as complementary ways of approaching reality, each requiring awe and reverence. He rejected dogmatic religion, but embraced a sense of cosmic wonder that guided his thought. By the early 1950s, Einstein had become more than a scientist or a public intellectual. He was a symbol. To many, he represented the capacity of the human mind to grasp profound truths about the cosmos. To others, he was a conscience for the modern age, a figure who used his fame not for personal gain, but to urge humanity toward peace and understanding. In the final months of his life, he remained active in both science and public discourse. His body grew frail, but his mind stayed sharp. Friends and colleagues who visited him in Princeton were struck by his continued passion for ideas, his humor, and his kindness. Though he had lived through wars, exile, and controversy, he retained a sense of optimism about the potential of human reason and cooperation. When Einstein passed away in April 1955, he left unfinished manuscripts on his desk, filled with equations and notes on unification. The quest that had driven his last decades remained unresolved, a reminder that even the greatest minds cannot answer every question. Yet the spirit of that quest, the belief that the universe is comprehensible, that its secrets can be uncovered through thought and persistence, remained as much a part of his legacy as his completed theories. In the final years of his life, Albert Einstein increasingly turned his attention away from scientific debate and toward the moral dilemmas of the nuclear age. He had spent decades advocating for peace, warning against nationalism, and urging international cooperation. But after 1945, Those appeals became more urgent. The devastation of Hiroshima and Nagasaki, followed by the nuclear arms race between the United States and the Soviet Union, convinced him that humanity faced an unprecedented danger. The very survival of civilization was at stake, and Einstein believed that scientists bore a special responsibility to speak out. Among those who shared his concern was the British philosopher and mathematician Bertrand Russell. Russell, like Einstein, combined intellectual achievement with outspoken advocacy for peace. In the early 1950s, as the Cold War deepened and hydrogen bombs entered the arsenals of the superpowers, Russell sought to rally leading thinkers to issue a public warning. He approached Einstein for support, knowing that Einstein's name carried extraordinary weight across the world. Despite his declining health, Einstein responded with enthusiasm. He agreed that scientists had a duty to address the threat posed by nuclear weapons directly. Together, Russell and Einstein drafted a statement that would come to be known as the Russell-Einstein Manifesto. The document, signed by 11 leading intellectuals and scientists, was released in July 1955, only a few months after Einstein's death. The manifesto was stark in its language. It described the catastrophic consequences of nuclear war, not only for the nations involved, but for humanity as a whole. It warned that the use of hydrogen bombs could mean the destruction of civilization and perhaps even the extinction of the human race. The signatories urged governments to recognize that war was no longer a rational option in an age of weapons of mass destruction. Instead, they called for peaceful resolution of disputes and greater international cooperation. One of the most memorable lines of the manifesto asked humanity to remember its shared humanity. It stated simply, "Shall we put an end to the human race, or shall mankind renounce war?" This direct appeal captured Einstein's lifelong belief that survival depended on transcending national rivalries and embracing a global perspective. The manifesto had a profound impact. It inspired the creation of the Pugwash Conferences on Science and World Affairs, an international movement that brought together scientists from different countries to discuss ways of reducing the nuclear threat. These conferences, which began in 1957, carried forward the spirit of Einstein's final appeal, fostering dialogue even during the most tense years of the Cold War. Decades later, the Pugwash movement would receive the Nobel Peace Prize for its contributions to nuclear disarmament. For Einstein, the manifesto represented the culmination of his political advocacy. Throughout his life, he had resisted war and nationalism, warned against blind obedience to authority, and urged humanity to recognize its shared destiny. His decision to lend his name to the manifesto, even as his health failed, was an act of conscience. It ensured that his final public statement was not about physics, but about peace. In his last days, Einstein remained active in correspondence and discussions. He continued to write letters to colleagues, friends, and political leaders, offering advice, encouragement, and warnings. Even when confined to his home by illness, he maintained a sense of responsibility to speak. He believed that silence in the face of danger was unacceptable, and he used his remaining strength to amplify the message of peace one final time. When the manifesto was released after his death, it was widely covered in newspapers and journals. Many noted the symbolism of Einstein's involvement, seeing it as a passing of the torch from one generation of thinkers to the next. His voice, silenced by death, still resonated through the words of the document. For millions, it was a reminder that the same mind that had unraveled the mysteries of space and time had also dedicated itself to protecting the fragile fabric of human society. The legacy of the manifesto extended beyond immediate politics. It represented the fusion of science and ethics, showing that intellectual achievement carried with it moral responsibility. Einstein's willingness to speak on issues far beyond his scientific expertise set a precedent for future scientists, encouraging them to consider not only what they could discover, but also how their discoveries might shape the world. In Princeton, the modest house on Mercer Street where Einstein had lived remained a place of pilgrimage for admirers and students of science. The release of the manifesto only deepened the sense that he had been not only a scientist, but also a moral leader. His final appeal echoed the themes that had run throughout his life: the pursuit of truth, the rejection of violence, and the belief that humanity's survival depended on cooperation and compassion. By the spring of 1955, Albert Einstein was 86 years old. His health had been declining for some time, though he continued to work, write, and correspond with colleagues and friends. In his small Princeton home on Mercer Street, piles of papers still covered his desk. Equations filled his notebooks, reflecting his relentless efforts on the unified field theory, the problem that had consumed him for decades. Even as his body weakened, his mind remained active and engaged. In mid-April, Einstein began experiencing severe abdominal pain. Doctors determined that he was suffering from an aortic aneurysm, a swelling in the main artery of the body. The condition was life-threatening, and surgery was possible, but Einstein declined aggressive treatment. He believed firmly that life should not be prolonged artificially when its natural course had reached its end. In his view, death was a part of life, not something to be feared or resisted at any cost. He expressed a desire to meet the end with dignity and without unnecessary medical intervention. Even during these final days, Einstein continued to work. Visitors to his hospital room found him scribbling notes and equations, still searching for the unifying principles of the cosmos. Nurses recalled that he kept asking for his notebooks and writing materials, refusing to abandon the pursuit that had defined his life. To him, the quest for understanding was not just a profession, but an inseparable part of his being. Einstein also remained true to his character in his reflections on mortality. He had long spoken of a cosmic religion, a sense of awe at the order and mystery of the universe. He did not believe in a personal God who intervened in human affairs, but he felt a deep reverence for the rational structure of nature. As he faced death, he accepted it calmly, without appeals to miracles or divine intervention. For him, the greatest miracle was the very existence of a universe comprehensible through reason. On April 18, 1955, Albert Einstein passed away at Princeton Hospital. The news spread quickly around the world. Newspapers carried headlines announcing the death of the man who had transformed science and become one of the most recognizable figures of the 20th century. Tributes poured in from scientists, political leaders, and ordinary citizens alike. Many remarked not only on his achievements in physics, but also on his moral courage and humanity. Einstein's wishes regarding his body were simple. He requested cremation without ceremony, preferring to avoid the creation of a public shrine. His remains were quietly cremated, and his ashes were scattered in an undisclosed location, in keeping with his desire for privacy. However, his brain was removed without his family's consent by the pathologist who conducted the autopsy, an act that later stirred controversy. For decades, fragments of Einstein's brain were studied in an attempt to find physical explanations for his extraordinary intellect, though the results were inconclusive and the ethics of the act questioned. In Princeton, his modest home on Mercer Street soon became a symbol of his legacy. Though private and unassuming, it represented the place where some of his final thoughts had taken shape. The Institute for Advanced Study, where he had spent his last 2 decades, continued as a center for research and reflection, forever linked to his presence. The immediate response to his death reflected the global reach of his influence. Scientists celebrated his revolutionary theories, which had redefined time, space, and energy. Political leaders recalled his advocacy for peace, his warnings about nuclear weapons, and his role as a conscience in troubled times. Ordinary people remembered his kindly appearance, his violin, his simple manner, and his ability to inspire wonder. Einstein's death marked the end of a remarkable life, but it also cemented his transformation into a figure of legend. For many, he symbolized the capacity of human thought to reach beyond the ordinary and grasp truths about the universe itself. For others, he represented the moral responsibility of intellect, the insistence that knowledge must be guided by compassion and justice. Though Einstein did not live to see the long-term impact of his final public act, the Russell-Einstein Manifesto, its release only months after his passing underscored the continuity of his vision. His last words to the world had been a plea for peace, a reminder that the future of humanity depended not on the brilliance of a few individuals, but on the collective choices of all people. The story of Einstein's final days reflects the essence of his life, a relentless pursuit of understanding, a quiet acceptance of nature's laws, and a deep concern for the fate of humanity. His body grew frail, but his spirit remained steady, and he faced the end as he had faced life, curious, reflective, and unafraid. The passing of Albert Einstein in April 1955 sent ripples across the world. News of his death appeared on the front pages of newspapers from New York to Tokyo, from London to Buenos Aires. The tributes came not only from fellow scientists, but from statesmen, writers, and ordinary citizens who felt that a unique voice had been silenced. Einstein's name had long since transcended the boundaries of physics. By the time of his death, he represented the very idea of genius itself. In the days following his death, reflections on his life emphasized two intertwined themes: his scientific revolution and his moral authority. Scientists hailed the theories of relativity as milestones in the understanding of the universe: the bending of light near the sun, the strange slowing of time at high speeds, and the equivalence of mass and energy had all become part of the foundation of modern physics. These ideas were not only mathematically profound, but also had practical consequences, shaping fields from cosmology to nuclear energy. The Nobel Prize he had received decades earlier was remembered as only a fraction of the recognition he deserved. At the same time, tributes highlighted Einstein's moral courage. Leaders and commentators recalled his outspoken opposition to fascism, his efforts to aid Jewish refugees, and his warnings about the dangers of nuclear weapons. His signature on the Russell-Einstein Manifesto was fresh in the public mind, and many saw it as a fitting final statement from a man who had dedicated his voice not only to science, but also to peace. His passing reminded the world that intellect and conscience could exist together in one figure. Public fascination with Einstein's personal life also deepened in the aftermath of his death. Stories circulated about his modest habits, his preference for simple clothing, and his absent-minded demeanor. Accounts of him walking through Princeton, lost in thought, or playing his violin for relaxation, added to the image of a man who, despite global fame, remained unaffected by luxury or vanity. This combination of extraordinary intellect and ordinary simplicity made him relatable, even as his ideas soared beyond common understanding. The controversy over the preservation of his brain added a peculiar dimension to his immediate legacy. The pathologist who performed his autopsy removed the brain without authorization, preserving it for study in the hope of discovering physical explanations for Einstein's intellectual powers. News of this act spread slowly, and reactions ranged from fascination to outrage. Some saw it as a violation of his wishes for privacy, while others viewed it as an opportunity to explore the biology of genius. For decades afterward, fragments of Einstein's brain would circulate among researchers, a strange testament to humanity's desire to probe even the physical foundations of his mind. Institutions also moved quickly to honor Einstein. The Institute for Advanced Study in Princeton, where he had worked for more than 2 decades, held commemorations that underscored his contributions to both science and the intellectual life of the community. Universities across the world organized lectures and conferences in his memory. His papers and correspondence began to be collected systematically, recognizing that they represented not only scientific history, but also insights into one of the most remarkable minds of the modern age. Einstein's death coincided with a period of intense global anxiety about nuclear war. The Cold War was escalating, and the superpowers were building ever more powerful weapons. Against this backdrop, his warnings carried even greater weight. Commentators noted the poignancy of his passing at a time when the world most needed voices of wisdom and restraint. His final public message, contained in the manifesto, was quoted widely, reminding people that the choice between survival and destruction lay in human hands. Among Jewish communities, Einstein was remembered both as a symbol of resilience and as a supporter of cultural renewal. His long advocacy for the Hebrew University of Jerusalem and his cautious support for the State of Israel were celebrated as evidence of his commitment to his heritage. At the same time, his universalist outlook, his insistence that nationalism of any kind must be tempered by global responsibility, resonated beyond any single community. For scientists of the younger generation, Einstein's death marked the end of an era. Many had grown up with his theories as the backdrop of their education. To them, he represented the highest ideal of the scientist: bold, original, and unafraid to challenge orthodoxy. Even those who disagreed with his views on quantum mechanics respected his integrity and admired his independence. His passing left a void, not just in physics, but in the culture of science itself. The image of Einstein that took hold immediately after his death was that of a sage, a figure whose white hair and kindly expression symbolized wisdom itself. His likeness soon appeared on posters, stamps, and in countless works of art. He became a cultural icon as much as a scientific one, embodying the belief that human reason could unlock the deepest mysteries of the universe while also guiding society toward greater justice and peace. This immediate legacy set the stage for how Einstein would be remembered in the decades to come, not only as the architect of relativity, but as a voice of conscience in the modern world, a man whose ideas reached from the stars to the most urgent problems of humanity. In the decades following Albert Einstein's death, his influence only grew stronger. His theories continued to shape physics, astronomy, and technology, while his image became embedded in global culture. Few scientists in history had combined profound intellectual achievement with such lasting symbolic power. Einstein had altered the foundations of science, and after his passing, the world began to measure just how far-reaching his impact truly was. In science, relativity moved from controversial theory to indispensable framework. General relativity became essential for understanding the cosmos. Astronomers used it to explain the behavior of stars, galaxies, and black holes. Predictions made by Einstein's equations guided discoveries that would have astonished him. In the 1960s, evidence for black holes began to emerge, confirming phenomena implied by his theory. Later, the detection of gravitational waves in the 21st century, produced by collisions of massive black holes, provided one of the most direct confirmations of relativity. Every such discovery reinforced Einstein's vision of a universe shaped by the curvature of space and time. Special relativity also found countless applications in technology. The principles underlying nuclear energy and particle accelerators traced back to Einstein's insights into mass energy equivalence. The precise timekeeping required for technologies like GPS relied on adjustments predicted by relativity, where clocks moving at high speeds or in stronger gravitational fields tick differently. What once seemed like abstract equations on paper became practical tools woven into everyday life. Quantum mechanics, the field Einstein had challenged, advanced in directions he had resisted. Yet even here, his influence was undeniable. His critiques, thought experiments, and skepticism forced others to sharpen their arguments. The concept of entanglement, which Einstein had introduced as a paradox to highlight what he saw as the incompleteness of quantum theory, later became central to new technologies in quantum computing and cryptography. In this way, even his objections seeded discoveries he never intended. Einstein's presence extended far beyond the laboratory. His face became one of the most recognized images in the world. Photographs of him with his wild hair, thoughtful eyes, and sometimes playful expressions appeared in classrooms, offices, and popular media. He was portrayed as the archetype of genius, the embodiment of creativity and originality. Cartoons, advertisements, and even films invoked his image or name to suggest brilliance or eccentricity. The famous photograph of him sticking out his tongue, taken in 1951, became one of the most reproduced images of the 20th century, symbolizing his sense of humor as well as his nonconformity. Culturally, Einstein became a figure claimed by many different communities and causes. Humanists admired his universalist outlook and his insistence on the dignity of all people. Pacifists cited his lifelong opposition to war and his calls for global governance. Jewish communities honored his commitment to education, his support for refugees, and his role in the establishment of the Hebrew University. Civil rights leaders in the United States pointed to his outspoken criticism of racism and segregation. In each of these areas, Einstein's words and actions continued to inspire long after his death. His writings also gained new audiences. Collections of his essays, letters, and reflections were published, offering readers not only his scientific insights, but also his thoughts on politics, philosophy, and ethics. These writings revealed a man deeply concerned with questions of meaning, responsibility, and the human condition. They showed that his genius was not limited to equations, but extended to moral reflection. Institutions honored him in numerous ways. His name was attached to schools, research centers, and awards. The Albert Einstein College of Medicine in New York, established during his lifetime, carried forward his commitment to science and humanitarian values. The Albert Einstein Memorial in Washington, D.C., unveiled in 1979, presented a larger-than-life bronze statue surrounded by inscriptions of his words, serving as a place of reflection for visitors from around the world. Einstein's influence also endured through the scientists he had inspired. Generations of physicists grew up studying his theories, testing their predictions, and extending their reach. Some pursued the unification he had sought, developing new frameworks such as string theory in an effort to reconcile gravity with quantum mechanics. Others applied his principles to explore the origins of the universe, leading to the development of the Big Bang theory, which drew upon relativity to describe cosmic evolution. In this way, his vision continued to shape the cutting edge of scientific exploration. Yet Einstein's legacy was not only one of triumph. His life also raised enduring questions about the relationship between science and society. The use of nuclear weapons haunted the world after 1945, and Einstein's role, however indirect, became part of the moral debate. His warnings about the dangers of technology without ethical guidance remained relevant as humanity faced new challenges, in fields such as genetics, computing, and artificial intelligence. His life stood as a reminder that knowledge and power must be tempered by responsibility. Einstein's enduring presence in popular imagination spoke to something deeper than scientific achievement. He represented the idea that a single individual, guided by curiosity and persistence, could change the world. His story, from a quiet child in Ulm to the most celebrated scientist of the modern age, inspired countless people to pursue knowledge and to believe in the power of thought. Decades after his death, Einstein remained a figure both revered and familiar. His equations shaped the universe of science, his image shaped the culture of genius, and his words shaped the conscience of humanity. Few lives have blended intellect, imagination, and moral conviction so completely, and few legacies have endured with such universal recognition. In the second half of the 20th century, Albert Einstein's legacy extended far beyond the boundaries of physics. His ideas reshaped education, influenced politics, and entered global conversations about the responsibilities of science and the role of intellect in society. Though he had passed away in 1955, his voice seemed to echo through classrooms, laboratories, and even diplomatic halls. Education was one of the first fields where his influence was deeply felt. Teachers and curriculum designers across the world introduced Einstein's theories not only as advanced science, but as an example of how human curiosity and imagination could overturn centuries of accepted thought. Relativity became part of high school and college textbooks, often presented as the pinnacle of modern scientific achievement. Even simplified, these lessons carried a sense of wonder, demonstrating that time and space themselves were not fixed but flexible. Students were taught that knowledge was not static, but could be transformed by bold insight. In this way, Einstein became a symbol of intellectual courage, encouraging generations of young people to think beyond convention. In universities, entire courses were built around his work. Graduate programs in physics expanded into areas of cosmology, astrophysics, and particle physics that drew directly upon Einstein's contributions. Theories he had once outlined with chalk on a blackboard became the basis for elaborate experiments involving satellites, telescopes, and particle accelerators. Relativity was no longer just a theory to be debated. It was a practical tool used to understand the universe on scales from the subatomic to the cosmic. Einstein's influence also extended into politics and international thought. The Cold War era magnified the importance of his warnings about nuclear weapons. Politicians and peace activists frequently quoted his calls for cooperation and his insistence that survival required transcending nationalism. Though governments often pursued arms races rather than disarmament, Einstein's words remained a reference point in debates about nuclear strategy and international law. His appeal for world governance, though not realized, influenced the growth of institutions such as the United Nations and movements advocating for stronger international agreements on arms control. Civil rights leaders in the United States drew inspiration from Einstein's outspoken opposition to racial segregation. His speeches and actions, such as his support for historically black colleges and his condemnation of discrimination, were remembered and cited by activists. For communities fighting injustice, Einstein's example demonstrated that even figures at the highest levels of science and fame could take moral stands. His voice added legitimacy to the idea that intellectuals had an obligation to confront prejudice. In global culture, Einstein became a shorthand for brilliance. His name was invoked in everyday conversation. A real Einstein became a common phrase to describe someone intelligent. His image appeared in art, cartoons, and advertisements. He became part of popular imagination, in a way few scientists ever had. The photograph of him sticking out his tongue appeared on posters and mugs, blending playfulness with genius. This cultural presence ensured that even people unfamiliar with relativity or physics knew Einstein as a figure representing intellect, creativity, and individuality. The publication of his writings, after his death, expanded his influence further. Collections of his essays and letters revealed the depth of his reflections on ethics, politics, and philosophy. Readers encountered not only a scientist, but a thinker concerned with the fate of humanity. His remarks on simplicity, humility, and the joy of discovery resonated with audiences beyond science. He spoke of the importance of curiosity, the value of questioning authority, and the need for compassion. These writings reached millions, shaping popular understanding of what it meant to live a thoughtful life. Scientific research, in the latter half of the century, continued to confirm and extend his theories. Astronomers applied relativity to study quasars, pulsars, and the expansion of the universe. Satellite technology required adjustments predicted by both special and general relativity, making his ideas indispensable to navigation and communication systems. The theory of relativity became not only a profound insight, but a practical necessity. Each new confirmation reinforced the sense that Einstein's vision had anticipated realities far beyond his own time. At the same time, debates he had engaged in with quantum theorists remained alive. His doubts about the completeness of quantum mechanics inspired continued exploration into the foundations of the field. Experiments in the 1960s and 1970s tested the phenomenon of entanglement, which Einstein had famously called spooky action at a distance. These experiments confirmed that quantum mechanics worked exactly as its supporters claimed, yet they also showed that Einstein had identified one of its most mysterious and important features. His challenge continued to shape scientific inquiry long after his death. Einstein's legacy also influenced discussions about the ethics of science, the nuclear age, the space race, and later developments in genetic engineering and computing raised questions about the responsibilities of scientists. Einstein's example, his refusal to separate knowledge from morality, became a guidepost. Universities and professional organizations invoked his words when debating the social responsibilities of research. His life demonstrated that brilliance in science did not absolve one of responsibility to humanity, but rather deepened it. By the late 20th century, Einstein was not only remembered as the discoverer of relativity, but as a symbol of the human spirit's capacity to question, to imagine, and to strive for justice. His theories continued to shape the frontiers of physics. His writings guided debates on peace and ethics, and his image remained an enduring emblem of genius. The world he left behind was profoundly different from the one into which he had been born, and much of that difference bore the imprint of his thought. As the mid-20th century unfolded, humanity turned its gaze outward to the cosmos, and Albert Einstein's theories became essential guides for this new exploration. Though he did not live to see rockets reach the moon or telescopes orbit the Earth, his vision of space and time provided the framework for understanding what lay beyond our planet. The space age, beginning with the launch of Sputnik in 1957 and continuing with missions to the moon, planets, and beyond, carried Einstein's legacy into the heavens. General relativity, completed in 1915, had been a bold statement about the nature of gravity. Einstein described space and time as dynamic, curved by the presence of mass and energy. For decades, this theory had been tested on Earth and through astronomical observations. But as technology advanced, space exploration provided new arenas where relativity was not only tested, but applied in practical ways. One of the most direct uses of Einstein's work appeared in navigation systems. When satellites were launched into orbit, Their clocks ticked at slightly different rates from those on Earth because of both their high speed and their weaker gravitational environment. Special relativity predicted the effect of motion on time, while general relativity accounted for the influence of gravity. Engineers who designed systems such as the Global Positioning System had to incorporate Einstein's corrections. Without them, GPS would accumulate errors that would make it useless within hours. This everyday reliance on relativity showed how Einstein's abstract equations had become woven into modern life. In astronomy, relativity reshaped understanding of the universe itself. The expanding universe, first inferred from observations in the 1920s, found theoretical grounding in Einstein's equations. Cosmologists used his framework to model the origins and evolution of the cosmos, leading to the widespread acceptance of the Big Bang theory. The discovery of the cosmic microwave background radiation in 1965 confirmed predictions rooted in relativity and transformed cosmology into a precision science. Einstein's equations, once written on chalkboards, now guided satellites scanning the skies. Relativity also predicted extreme objects that became central to astrophysics, black holes. These were regions where gravity was so strong that not even light could escape, warping space-time to its limits. For years, black holes seemed like mathematical curiosities, but in the 1960s and 1970s, evidence began to mount that they existed in reality. Observations of stars orbiting invisible companions and the detection of X-rays from collapsed stellar remnants pointed toward their presence. By the late 20th century, black holes were widely accepted as real, confirming one of Einstein's most dramatic predictions. The study of gravitational waves further extended Einstein's reach into the space age. In 1916, he had predicted that massive objects in motion would send ripples through the fabric of space-time. These waves would be incredibly faint, far beyond the ability of instruments of his era to detect. Decades later, scientists built detectors capable of measuring these subtle vibrations. In 2015, the Laser Interferometer, Gravitational Wave Observatory, announced the first direct detection of gravitational waves from merging black holes, exactly as Einstein had described a century earlier. This achievement, awarded the Nobel Prize in Physics, underscored the enduring accuracy and power of his vision. Einstein's influence extended to the exploration of planets and the development of space technology as well. Relativistic corrections improved the precision of spacecraft trajectories, ensuring missions could reach their destinations across vast distances. The bending of light by gravity, first confirmed during the 1919 eclipse, became a practical tool known as gravitational lensing, allowing astronomers to observe distant galaxies magnified by intervening masses. These techniques opened new windows onto the universe, all rooted in the theory Einstein had formulated in Berlin before the First World War. The symbolism of Einstein also permeated the cultural imagination of the space age. As astronauts ventured into orbit and humans walked on the moon, the language of relativity and space-time entered popular accounts of exploration. Einstein's name was invoked as a touchstone for the mysteries of the cosmos, a reminder that the leap into space was also a leap into a universe shaped by his equations. Popular science books, documentaries, and classroom lessons presented him as the intellectual forerunner of space travel, even though rockets owed more to engineering than to relativity. His work gave cosmic exploration its intellectual foundation. As humanity extended its reach into the solar system, Einstein's ideas provided both practical guidance and philosophical depth. He had shown that the universe was not a static backdrop, but a dynamic, evolving structure. This vision resonated with the discoveries of distant galaxies, cosmic expansion, and the search for life beyond Earth. Space exploration gave concrete expression to his abstract insights, making them part of humanity's collective journey. The space age thus amplified Einstein's legacy. His equations were no longer confined to laboratories and observatories. They were written into the flight paths of spacecraft, the signals of satellites, and the lenses of telescopes peering to the edge of the observable universe. In each new discovery, his presence lingered, a reminder that the human mind could imagine and predict realities far beyond immediate experience. By the late 20th century, Albert Einstein's presence extended well beyond science, entering the realms of art, philosophy, and popular culture. While his theories continued to guide astrophysicists and cosmologists in their explorations of space and time, his face and words became fixtures in classrooms, living rooms, and cultural movements around the world. He was not only the architect of relativity, but also an icon of creativity, freedom of thought, and resistance to conformity. Einstein's image, with his white hair and often bemused expression, became one of the most recognizable in history. Photographs of him circulated globally, appearing in textbooks, magazines, and even advertisements. The 1951 snapshot of him sticking out his tongue, taken after a birthday celebration, became especially famous, symbolizing his playfulness and refusal to take himself too seriously. This photograph alone captured a side of genius that resonated with younger generations. Brilliance paired with irreverence. Artists drew heavily on Einstein as a source of inspiration. Painters, sculptors, and photographers portrayed him as a modern sage. Murals featuring his face appeared on city walls, while surrealist and pop art movements wove his likeness into explorations of time and perception. His equations, particularly E=mc², appeared in unexpected places, from fine art galleries to t-shirts and posters. The formula, once confined to physics journals, became shorthand for intellect itself. Writers and philosophers also engaged with Einstein's legacy. His reflections on time, space, and determinism influenced discussions in metaphysics and the philosophy of science. Novelists used relativity as a metaphor for shifting perspectives, while poets invoked his name to suggest profound insight. In many works, Einstein stood as a figure who blurred the line between science and philosophy, demonstrating that discoveries about the cosmos could also reshape human self-understanding. Einstein's influence reached into popular counterculture movements of the 1960s and 1970s. His outspoken opposition to war, his advocacy for civil rights, and his simple lifestyle aligned with values embraced by student movements and anti-establishment groups. Protesters carried his quotes on signs, musicians referenced him in lyrics, and his face appeared alongside peace symbols on banners and posters. In an age questioning authority and tradition, Einstein represented the power of independent thought and moral courage. The broader public embraced Einstein not only as a scientist, but as a kind of cultural hero. Schools named after him multiplied, libraries and museums dedicated exhibitions to his life, and science outreach often used him as a gateway figure to spark curiosity. Children learning about science for the first time encountered his story as an example of how imagination could transform knowledge. Teachers highlighted his struggles as a student to remind learners that brilliance often emerges from persistence rather than effortless success. Einstein's writings on politics, peace, and humanity gained renewed attention in these decades. Collections of his essays, such as Ideas and Opinions, became widely read, offering insight into his moral philosophy. Readers discovered a man who valued simplicity, distrusted dogma, and placed compassion above ambition. His phrase, "Imagination is more important than knowledge," appeared everywhere, sometimes simplified, but always pointing to his belief in creativity as the heart of discovery. These words resonated not just with scientists, but with artists, educators, and activists. The global spread of Einstein's image also reflected the rise of mass media. Television documentaries presented his life story, dramatizing the revolution of relativity. Films referenced him as a cultural touchstone, sometimes humorously, sometimes reverently. Science fiction works imagined conversations with him or invoked his theories to lend credibility to futuristic plots. The blending of Einstein with popular imagination blurred the line between historical figure and cultural myth. His reputation was not without complexity. While celebrated universally, some critics noted that his iconization risked oversimplifying his work and reducing a life of deep inquiry into clichés. Yet even this criticism underscored his unusual position. No other scientist had become so firmly lodged in the public imagination. Einstein had become more than himself. He was a symbol of the potential of human thought. By the end of the 20th century, Einstein's influence in culture paralleled his influence in science. Just as his equations guided satellites and telescopes, his face and words guided artists, writers, and activists. He was invoked in conversations about creativity, freedom, and responsibility. His presence in culture showed that science was not a separate realm, but part of the broader fabric of human life. Einstein's journey from a quiet boy in Ulm to a global icon of intellect and imagination captured something universal: the belief that one mind, through curiosity and persistence, could reshape both knowledge and culture. His continuing presence in art, philosophy, and popular movements reflected that belief, ensuring that his name would remain not only in the history of physics, but in the shared cultural heritage of humanity. As the 20th century drew to a close and the digital age began, Albert Einstein's legacy found new dimensions. His theories, once abstract statements about the universe, became part of the infrastructure of modern computing and communications. At the same time, his philosophy of creativity, imagination, and responsibility resonated in a world transformed by digital technology. The age of satellites, networks, and information owed much to the foundations Einstein had laid, both scientifically and culturally. Relativity, developed in the early years of the 20th century, proved essential for the functioning of digital technologies that emerged decades later. The rise of global positioning systems depended directly on Einstein's corrections to Newtonian time and space. Satellites orbiting Earth experienced time differently than clocks on the ground, due to both their speed and their distance from the planet's gravitational pull. Without adjusting for these relativistic effects, GPS signals would drift quickly, leading to errors of kilometers within a single day. The entire architecture of modern navigation, from smartphones to aviation systems, relied on Einstein's insights into the relativity of time. Digital communications also benefited from Einstein's work. Satellite links transmitting data across the globe required precise synchronization, made possible by relativistic corrections. Fiber optic systems, which guided beams of light across continents, carried echoes of his dual description of light as both wave and particle. While not all applications were direct, the digital revolution consistently found itself shaped by concepts Einstein had pioneered. Beyond the practical, Einstein's philosophy spoke to the emerging digital culture. He had emphasized imagination as a driver of progress, warning against rigid thinking and blind adherence to authority. In the world of computing, where innovation depended on creative approaches to problems, his words found new audiences. Entrepreneurs, programmers, and educators often cited Einstein to encourage experimentation and nonconformity. His belief that curiosity mattered as much as formal training resonated with a generation building technologies in garages and laboratories alike. Einstein's famous skepticism about uncertainty also had surprising relevance in the digital era. While he resisted the probabilistic nature of quantum mechanics, his discussions of entanglement later inspired fields such as quantum computing and quantum encryption. Researchers exploring these frontiers acknowledged that Einstein, even in his doubts, had pointed toward phenomena that would shape the next wave of digital technology. The very paradox he had raised as a criticism became a foundation for new advances. The cultural image of Einstein also adapted smoothly to the digital world. His likeness appeared in computer graphics, online memes, and internet culture. The photograph of him sticking out his tongue became one of the most widely shared images in early online communities, symbolizing wit and rebellion in a medium defined by informality. Educational websites and digital learning platforms used his story as an entry point to explain science, making him a guide for millions of learners encountering physics in virtual classrooms. As computing expanded into artificial intelligence, Einstein's legacy found yet another connection. His lifelong search for unity and simplicity echoed in the ambitions of AI researchers who sought to build systems capable of uncovering patterns in vast amounts of data. While his own work belonged to the analog age of pen, paper, and chalkboards, his spirit of inquiry seemed aligned with the new digital quest to understand complexity through computation. Einstein's humanistic writings also spoke to the ethical dilemmas of the digital era. His insistence that knowledge must be guided by compassion found renewed relevance as societies faced questions about privacy, surveillance, and the concentration of technological power. Just as he had warned about the destructive potential of nuclear weapons, his example reminded digital pioneers that innovation without ethics could endanger humanity. His voice, though long silent, echoed in debates about responsibility in technology. Educational institutions in the digital age amplified Einstein's presence through online archives and digital libraries. His letters, manuscripts, and photographs were scanned and made available to anyone with an internet connection. For the first time, students and enthusiasts across the globe could read his personal reflections and study his original papers directly. This democratization of access reinforced his belief that knowledge belonged to all, not just to an elite few. In popular media, Einstein continued to appear as a character and symbol. Films, television series, and later streaming platforms invoked his name to suggest brilliance or eccentricity. Video games and virtual reality experiences referenced his theories, using relativity as a narrative device to bend time and space in imaginative ways. His legacy found playful as well as serious expression in the digital imagination. By the early 21st century, Einstein's influence on the digital age was both practical and symbolic. His theories powered the systems that connected the world, while his persona embodied the values of creativity and responsibility that digital culture aspired to. The scientist who once filled notebooks in solitude had become a global companion for billions, navigating a new technological landscape. Einstein's place in the digital age reflected the continuity of his legacy. He had revealed the relativity of time and space, and his insights continued to guide the most advanced technologies. He had spoken of imagination as the heart of discovery, and his words inspired innovation in a new medium. He had warned of the dangers of unchecked power, and his example reminded the digital world of its ethical obligations. In these ways, Einstein remained not only a figure of the past, but a living presence in the digital present. Albert Einstein's legacy did not end with the physics that redefined the universe or the technologies that applied his theories. His writings, reflections, and way of life carried philosophical weight, influencing how people thought about meaning, morality, and the human place in the cosmos. As the 20th century advanced, a century marked by both dazzling scientific triumphs and profound existential anxieties, Einstein became a voice not just of scientific authority, but of philosophical guidance. Einstein was not a professional philosopher, yet his comments on knowledge, ethics, and religion resonated with thinkers across disciplines. He consistently emphasized humility before the mysteries of existence. For him, science revealed not certainty, but glimpses of a rational order, far greater than any single human mind could comprehend. He described this stance as a cosmic religious feeling, a sense of awe at the structure of the universe. Unlike traditional religion, his vision had no room for dogma or divine intervention in daily affairs. Instead, it reflected reverence for the laws of nature and the unity underlying them. Philosophers engaged with these ideas in many ways. Some saw Einstein as a bridge between science and spirituality, a figure who demonstrated that rational inquiry need not eliminate wonder. Others viewed him as a model of scientific realism, convinced that nature's laws existed independently of human perception, and that science's task was to uncover them. Still others found inspiration in his belief that morality was a human creation, grounded in compassion and responsibility rather than divine command. Einstein's reflections on ethics became particularly influential. He argued that intellectual achievement carried moral obligations. Knowledge without conscience, he warned, could become destructive. His life demonstrated this conviction. He had spoken out against militarism, condemned racism, and urged international cooperation. His words reminded future generations that science was never separate from society, but deeply enmeshed within it. In this way, Einstein became a model for the socially responsible intellectual. In the wider culture, his philosophy appealed to those searching for meaning in an age of uncertainty. The 20th century had seen 2 world wars, genocide, and the threat of nuclear annihilation. For many, traditional frameworks of certainty seemed shaken. Einstein's voice, calm and reflective, offered an alternative. He acknowledged the limits of human knowledge, but affirmed the value of curiosity, compassion, and truth. His insistence on simplicity, both in science and in life, suggested that meaning could be found not in grand systems, but in honest engagement with reality. Einstein's philosophy also shaped educational thought. He emphasized creativity over rote learning, encouraging teachers to nurture imagination and curiosity. He often said that questions mattered more than answers, and that true education cultivated the ability to think independently. These ideas influenced educators around the world, reinforcing the importance of inquiry-based learning. His belief that joy and play were integral to discovery resonated far beyond physics classrooms. In debates about free will and determinism, Einstein's voice also carried weight. His rejection of quantum indeterminacy stemmed from his conviction that the universe operated according to consistent laws. He saw human freedom not as a break from causality, but as part of the larger rational order of nature. This perspective influenced philosophical discussions about the relationship between science and human agency, offering a vision of freedom grounded in understanding rather than randomness. Einstein's approach to politics likewise reflected philosophical commitments. He distrusted authority, resisted conformity, and advocated for democratic values. He believed that loyalty to humanity as a whole outweighed loyalty to any nation. His support for world government, though criticized as utopian, expressed his conviction that ethics must be universal in an interconnected world. His writings on these subjects continued to inspire philosophers of politics, peace, and human rights. Perhaps the most enduring aspect of Einstein's philosophy was his insistence on balance between curiosity and humility, between knowledge and responsibility, between individuality and community. He saw life as meaningful, not through certainty, but through the pursuit of understanding and the practice of compassion. This message carried weight for scientists, philosophers, and ordinary people alike. In the years after his death, Einstein's words appeared in anthologies of wisdom, alongside those of philosophers and spiritual leaders. His reflections on imagination, simplicity, and humanity's shared destiny were quoted in classrooms, sermons, and speeches. Even outside the context of physics, his ideas shaped how people thought about life's deepest questions. Einstein's philosophical influence showed that science was not an isolated enterprise. It was part of the broader human search for meaning. His life demonstrated that the pursuit of knowledge could coexist with moral commitment, and that intellect could serve both truth and justice. In a century that often seemed fragmented, his voice offered a vision of unity between science and philosophy, between reason and wonder, between knowledge and compassion. As the 21st century began, Albert Einstein's legacy remained not only intact, but more relevant than ever. His theories continued to guide the frontiers of physics, while his name and image remained cultural touchstones across the globe. In science, technology, education, and ethics, Einstein's presence shaped both the questions people asked and the ways they sought answers. The dawn of the new century confirmed that his influence was not confined to the past. It was a living force woven into modern life. In physics, Einstein's general relativity reached new heights of confirmation. Astronomers and physicists used space-based observatories, powerful telescopes, and advanced detectors to test his predictions with precision far beyond what was possible in his lifetime. The discovery of gravitational waves in 2015 marked a triumph for relativity, directly confirming a prediction Einstein had made a century earlier. The detection of these ripples in space-time, caused by the collision of massive black holes, was celebrated worldwide as both a technological achievement and a vindication of Einstein's vision. Further discoveries deepened his legacy. In 2019, the Event Horizon Telescope released the first direct image of a black hole's shadow, an observation possible only through the lens of general relativity. The bright ring of light, bending around the dark center, offered visual proof of phenomena Einstein's equations had foretold. Each new discovery in cosmology, from the mapping of the cosmic microwave background to the measurement of dark energy driving the expansion of the universe, was interpreted within frameworks built upon his work. Relativity was no longer just a theory, it was the scaffolding of modern cosmology. In technology, Einstein's influence continued through the global reliance on GPS, satellite communications, and systems requiring precise time measurement. Engineers routinely applied relativistic corrections, ensuring that satellites aligned with predictions of both special and general relativity. Everyday tools, such as navigation apps or synchronized financial networks, depended on concepts Einstein had introduced decades earlier. His insights had moved from blackboards to pocket devices, affecting billions of lives daily. Culturally, Einstein's image retained its extraordinary power. His face appeared in advertisements, educational campaigns, and digital media. The internet amplified his presence, turning his quotes and photographs into some of the most widely shared cultural symbols online. Memes, videos, and social media posts often invoked him as shorthand for intelligence, creativity, or humor. The photograph of him sticking out his tongue, once a private joke, became an emblem of playful rebellion in the digital age. Einstein's writings, digitized and made globally accessible, extended his reach into classrooms and homes worldwide. Archives published his scientific papers, personal letters, and philosophical reflections online, allowing new generations to engage directly with his words. Students could read his thoughts on relativity alongside his reflections on humanity, discovering a figure whose depth extended beyond equations. His belief that imagination mattered as much as knowledge resonated strongly in an era defined by creativity, innovation, and global connectivity. The 21st century also revived debates Einstein had raised but never resolved. Quantum entanglement, which he had once criticized as spooky action at a distance, became the foundation of research in quantum computing and quantum communication. Experiments repeatedly confirmed that entanglement was real and exploitable, yet scientists acknowledged that Einstein's challenge had forced them to clarify and strengthen the theory. In this way, even his doubts continued to inspire progress. Einstein's moral legacy found new relevance as well. His warnings about technology without ethics applied not only to nuclear weapons, but also to challenges in artificial intelligence, biotechnology, and climate change. Leaders and thinkers often quoted his words when discussing the need for compassion and responsibility in the face of global risks. His advocacy for peace, equality, and justice inspired movements that sought to balance scientific advancement with human values. Einstein's influence on education expanded with the growth of online learning. His story became a staple of science outreach, used to inspire curiosity and confidence in students worldwide. Programs emphasized his struggles in school as proof that unconventional paths could lead to greatness. His perseverance, independent thinking, and imagination were held up as examples for learners in every field, from physics to art. In global consciousness, Einstein continued to stand as the ultimate symbol of genius. His name appeared on schools, research institutes, awards, and even consumer products. He became part of the language itself, invoked as a comparison whenever intelligence or creativity was discussed. Few figures in history achieved such universal recognition, spanning cultures, languages, and generations. As humanity entered a new century, Einstein's presence served as both inspiration and challenge. He demonstrated the power of reason and imagination to reshape knowledge, but he also reminded humanity of its responsibility to use that power wisely. His theories guided exploration of the cosmos. His image fueled creativity, and his words cautioned against arrogance and division. In every dimension of modern life, from the phones in pockets to the telescopes peering into distant galaxies, the imprint of Einstein remained unmistakable. In the 21st century, Albert Einstein became as much a figure of education and imagination as of scientific history. His theories continued to shape research at the highest levels of physics, but his story also served as an entry point for millions of students encountering science for the first time. Across classrooms, museums, and digital platforms, Einstein's life and ideas were presented not just as lessons in physics, but as symbols of curiosity, perseverance, and creativity. Teachers often used Einstein's early struggles in school to inspire students. Accounts of him being slow to speak as a child, or of his discomfort with rigid teaching methods, reminded learners that success does not always follow a smooth path. His ability to question authority and think independently became an example of how unconventional minds can make extraordinary contributions. By framing Einstein as someone who challenged norms rather than conform to them, educators highlighted the value of imagination alongside discipline. Educational institutions worldwide carried his name. Schools, universities, and research centers adopted the title Einstein to associate themselves with intellectual achievement. The Albert Einstein College of Medicine in New York, founded during his lifetime, continued to train new generations of doctors and researchers. Science museums curated exhibits around his theories, combining interactive demonstrations with stories about his life. These institutions kept his legacy alive, not only as historical fact, but as a living inspiration. Digital education expanded Einstein's reach even further. Online courses introduced relativity to global audiences, often beginning with simplified explanations of time dilation, curved space, and the famous equation E=mc². Videos, animations, and virtual simulations allowed students to visualize concepts that once existed only on paper. Einstein's ideas, once the domain of advanced physicists, became accessible to anyone with an internet connection. His legacy as a teacher extended far beyond the lectures he had given in Zurich or Berlin. Einstein also remained a presence in children's education. Picture books, cartoons, and simplified biographies presented him as a friendly guide to the wonders of science. Stories emphasized his curiosity as a boy, his fascination with a compass, and his persistence in solving puzzles. By introducing children to Einstein early, educators fostered the idea that science was not distant or intimidating, but a natural extension of curiosity about the world. Beyond formal education, Einstein flourished in popular imagination. His likeness appeared in films, television, and literature, often as the archetypal genius. Sometimes he was portrayed humorously, sometimes reverently, but always as a figure representing human creativity. His name became shorthand for brilliance, invoked whenever intelligence was discussed. Even those who knew little about relativity recognized Einstein as the symbol of genius. Philosophical reflections on his life also reached wide audiences. His quotes on imagination, simplicity, and the importance of curiosity circulated widely, especially in digital spaces. Many of these quotations were simplified or paraphrased, yet they captured the essence of his outlook. They reminded people that discovery required openness and humility, and that knowledge was not merely a collection of facts, but a way of engaging with the universe. Einstein's connection to imagination extended into the arts. Writers, painters, and filmmakers invoked relativity as a metaphor for shifting perspectives and flexible realities. His theories inspired creative explorations of time travel, parallel universes, and altered perceptions of reality. Science fiction in particular embraced Einstein, using his concepts as springboards for imaginative stories. In this way, his influence shaped not only scientific understanding, but also cultural creativity. For many, Einstein's role in education and imagination was inseparable from his moral presence. His example demonstrated that great intellect must be coupled with ethical awareness. Teachers emphasized not only his scientific breakthroughs, but also his advocacy for peace, his opposition to racism, and his humanitarian values. In classrooms, Einstein was introduced not only as a physicist, but as a thinker who believed in justice and compassion. The persistence of Einstein in education and imagination showed that his legacy was not confined to specialists. He belonged to humanity as a whole, accessible to children learning about a compass, to students grappling with relativity, and to artists exploring the boundaries of perception. His life illustrated the unity of knowledge and imagination, the blending of curiosity with conscience. By the early decades of the 21st century, Einstein remained a bridge figure. He connected the abstract world of equations with the everyday questions of meaning and wonder. He linked the rigor of science with the playfulness of creativity. His story reminded humanity that to understand the universe was also to celebrate imagination, perseverance, and responsibility. As the 21st century unfolded, Albert Einstein's legacy continued to influence not only science and education, but also debates about ethics and global responsibility. His life offered an enduring example of how intellectual achievement could be joined with moral commitment. Long after his death, his words about peace, justice, and humanity remained central to discussions about the role of science and technology in an interconnected world. Einstein's opposition to nationalism and militarism carried renewed weight in an era defined by global challenges. He had warned that humanity could not survive if nations clung to narrow interests, and his call for international cooperation echoed in debates about climate change, nuclear disarmament, and global inequality. Leaders and activists frequently cited his conviction that loyalty to humanity must outweigh loyalty to nation. His belief that war had become obsolete in the age of nuclear weapons served as a constant reminder of the stakes in global politics. His stance on ethics and science also remained highly relevant. Einstein had insisted that scientific discovery alone was not enough, that researchers bore responsibility for the consequences of their work. In a world grappling with artificial intelligence, genetic engineering, and environmental change, this principle resonated deeply. Universities and scientific organizations invoked his example when developing ethical guidelines, emphasizing that knowledge must serve humanity rather than endanger it. Einstein's writings on racism and social justice also spoke powerfully in later decades. His denunciation of segregation in the United States and his support for civil rights leaders were remembered as part of his moral legacy. Activists cited his example to argue that intellectuals and public figures had an obligation to confront prejudice and injustice. His willingness to use his fame to highlight inequality made him a model for socially engaged scholars. In discussions about religion and philosophy, Einstein's perspective offered a path between dogma and disbelief. His description of a cosmic religious feeling, a reverence for the rational order of the universe, provided inspiration for those seeking meaning without rigid doctrines. His approach encouraged dialogue between science and spirituality, showing that awe and reason could coexist. In an age often divided between extremes, his balanced voice provided a bridge. Einstein also became a symbol in conversations about global education and equality. His belief that curiosity mattered more than memorization inspired reforms in teaching methods. Educational programs in developing countries invoked his story as a reminder that genius could emerge anywhere if nurtured with opportunity. His life reinforced the idea that knowledge belonged to all humanity, not just to privileged elites. At the level of international institutions, Einstein's advocacy for world government and cooperation influenced thinkers who sought stronger global governance. While his specific proposals were never realized, his vision helped shape the moral foundations of organizations such as the United Nations and movements for human rights. His insistence that survival required transcending borders resonated especially in discussions about nuclear arms control and environmental stewardship. Einstein's ethical influence extended into popular culture as well. His quotes about peace and responsibility appeared in art, music, and media campaigns. Posters and films invoked his name to highlight the dangers of war or the promise of cooperation. In these contexts, Einstein functioned as a symbol of conscience, reminding audiences that intellect must be coupled with compassion. The durability of Einstein's ethical legacy reflected the coherence of his life. He was not a figure who separated science from society or intellect from morality. He lived in a way that integrated discovery with responsibility, theory with humanity. This integration made his example adaptable to new challenges. Whether the issue was nuclear weapons, digital technology, or climate change, Einstein's life provided guidance on how to balance knowledge with conscience. By the 21st century, Einstein had become not only a historical figure, but a timeless presence in global ethical thought. His image symbolized brilliance, but his words symbolized responsibility. He demonstrated that genius was not only about solving equations, but about asking what those solutions meant for humanity. In an interconnected world, facing challenges of survival, justice, and cooperation, Einstein's legacy reminded people that intellect and ethics must advance together. He showed that to understand the universe was also to recognize humanity's place within it, and to act with humility and compassion. By the 21st century, Albert Einstein was more than a figure from the history of physics. He had become a central symbol in the way society thought about science itself. His name and image were inseparable from the idea of genius, and his story became a cornerstone of how science was communicated to the public. From classrooms to documentaries, from children's books to global media, Einstein served as the gateway through which millions encountered the wonders of discovery. Science communication found in Einstein a perfect subject. His theories were profound, yet the core ideas could be expressed in images and metaphors that sparked imagination. Light bending around the sun, clocks ticking at different rates, mass transformed into energy. These visualizations made relativity a story that could be told beyond equations. Popular science writers and educators used Einstein's discoveries to introduce readers and viewers to the vastness of the cosmos and the subtlety of physical law. In this way, Einstein became not only a scientist, but a storyteller of the universe, even decades after his death. The image of Einstein also shaped how society celebrated genius. His wild hair, thoughtful eyes, and playful expressions came to symbolize the eccentric brilliance of the thinker absorbed in ideas. Cartoons and films often used Einstein-like characters to represent inventors or visionaries. His tongue-out photograph, reproduced endlessly, showed that genius could be lighthearted as well as profound. This combination of intellect and humor made him accessible, breaking down barriers between scientific achievement and popular culture. In education, Einstein's life story was used to humanize science. Teachers emphasized not only his theories, but also his persistence, his struggles, and his independence. Students learned that Einstein had been doubted, even dismissed by teachers early in life, yet went on to transform physics. This narrative encouraged learners to see failure as part of discovery and curiosity as the key to innovation. His biography became a lesson in resilience, as much as in relativity. Museums and exhibitions around the world dedicated galleries to Einstein. Interactive displays allowed visitors to experiment with simulations of time dilation, gravity wells, and light bending. These exhibits used Einstein's work to make abstract physics tangible, reinforcing the idea that his discoveries were not only profound but approachable. In the digital era, online platforms recreated these experiences for global audiences, making Einstein a guide for virtual exploration of the universe. Einstein's influence on science communication also extended to television and film. Documentaries about the cosmos routinely featured him as a central figure, often beginning with relativity before expanding into modern astrophysics. Films and series used his theories as narrative devices, bending time and space in ways inspired by relativity. Even when simplified or fictionalized, these portrayals reinforced Einstein's presence in the cultural imagination. He was both a historical figure and a character who embodied the possibilities of science. The celebration of Einstein as genius also reflected broader cultural values. He represented not only intelligence, but creativity, independence, and moral responsibility. Unlike depictions of genius as aloof or authoritarian, Einstein's image emphasized humility and humanity. He walked through Princeton in old clothes, played violin for relaxation, and joked with friends. This approachable genius contrasted with stereotypes of cold intellectualism, offering a model of brilliance that was warm and inspiring. His story also helped frame the relationship between science and society. Einstein's public advocacy for peace and justice demonstrated that intellect was not confined to laboratories. Communicators used his example to argue that scientists had a duty to engage with public life, to speak about the ethical consequences of their work. In this way, Einstein shaped not only the narrative of science itself, but also the role of scientists as citizens. In popular culture, Einstein became a universal reference point. His name was used in everyday language. Calling someone an Einstein meant calling them exceptionally smart. Advertisements used his likeness to suggest intelligence or creativity in products ranging from computers to children's toys. Even when detached from physics, the symbol of Einstein carried weight, representing the potential of the human mind. The idea of genius itself was reshaped through Einstein. He showed that genius was not about memorization or conformity, but about imagination, persistence, and courage to challenge assumptions. His life embodied the notion that genius could emerge from questioning the obvious, from seeing the familiar in new ways. In celebrating Einstein, society celebrated these values, passing them on to new generations. By the modern era, Einstein was not only remembered as the father of relativity, but as the face of scientific imagination itself. He bridged the gap between complex theories and public understanding, between intellect and humanity. In him, science communication found both a subject and a symbol, a story that could inspire curiosity, and a figure that could embody the joy of discovery. As the 21st century advanced, Albert Einstein's presence in global culture only deepened. His name, image, and words appeared in countless settings, from international science festivals to everyday conversations. He had become more than a historical figure. He was a symbol of human potential, a unifying reference point across cultures, languages, and generations. Science festivals around the world frequently placed Einstein at the center of their themes. Posters displayed his face. Workshops explained his theories in simplified form, and lectures invoked his name as shorthand for curiosity and discovery. To organizers, Einstein embodied the spirit of science itself, bold, imaginative, and transformative. Festivals used his story to connect with audiences of all ages, showing that the pursuit of knowledge could be as inspiring as art or music. Media representations reinforced this cultural role. Documentaries revisited his life with fresh perspectives, dramatizing his struggles and breakthroughs. Television series and films often portrayed him as a character, sometimes in serious depictions, other times in humorous cameos. Animated shows for children referenced Einstein to spark interest in science, while popular dramas invoked his theories to add depth or mystery. In each context, his presence provided both recognition and credibility. Einstein's influence extended into art and design. His wild-haired silhouette became an artistic motif, appearing on murals, sculptures, and even graffiti. His famous equation was painted on walls, printed on clothing, and incorporated into jewelry, serving as both a scientific formula and a cultural emblem. Artists used Einstein not only to symbolize intellect, but also to represent creativity and the courage to see the world differently. In literature, Einstein often appeared as a touchstone for reflection on knowledge, imagination, and time. Poets invoked his theories to explore shifting realities, while novelists used his name as a symbol of intellectual depth. Science fiction drew heavily on relativity, weaving concepts of time dilation and curved space into stories of interstellar travel. Through these works, Einstein became part of humanity's collective imagination of the cosmos. His words continued to circulate widely in popular culture. Quotes about imagination, simplicity, and humanity's shared destiny appeared on posters, websites, and social media feeds. While some quotations were paraphrased or simplified, they captured the spirit of his outlook. People turned to Einstein's words for encouragement in creativity, comfort in uncertainty, and guidance in ethics. His voice, preserved in text, became a source of wisdom across contexts far removed from physics. Einstein's image also played a role in global identity. Nations, cities, and institutions claimed connections to his legacy. Germany, where he was born, celebrated him as part of its intellectual heritage. Switzerland highlighted his years of study and work in Zurich and Bern. The United States, where he lived his final decades, honored him as a symbol of scientific achievement and immigrant contribution. Israel remembered him as a supporter of Jewish education and culture. In each place, Einstein served as a bridge between local pride and universal significance. Educational campaigns frequently used Einstein to promote science literacy. His story of curiosity as a child, fascinated by a compass, and his persistence in challenging assumptions were presented as models for students. International organizations, including UNESCO and the United Nations, invoked his legacy to emphasize the importance of education, peace, and cooperation. Through these efforts, Einstein's name became tied not only to knowledge, but to the ideals of global citizenship. Einstein's moral authority continued to resonate in political and social debates. Advocates for disarmament cited his warnings about nuclear weapons. Campaigners for racial equality remembered his criticism of segregation. Environmental activists invoked his call for responsibility in science. In each case, Einstein served as a reminder that intellect must be joined with conscience. His legacy provided a moral compass as much as a scientific framework. Even in everyday conversation, Einstein remained present. To call someone an Einstein was to acknowledge their intelligence, and his name appeared in jokes, compliments, and casual remarks across cultures. His tongue-out photograph circulated endlessly, representing humor and humanity alongside brilliance. This combination of relatability and profundity ensured that Einstein remained accessible as a cultural icon. By the early decades of the 21st century, Einstein stood as one of the most universally recognized figures in history. His theories shaped the frontiers of physics, his writings guided ethical thought, and his image symbolized genius and creativity. He was at once a scientist, a philosopher, a moral voice, and a cultural symbol. In Einstein, humanity found a figure who united intellect with imagination, knowledge with compassion, and science with culture. His global presence reflected not only his personal achievements, but also the shared human longing for understanding and meaning. Albert Einstein's life closed in 1955, but his influence has continued to stretch across decades, shaping science, culture, education, and ethics. Few figures in history have left such a profound and lasting imprint. His theories redefined the structure of the universe. His words guided humanity's moral reflection, and his image became a universal symbol of genius and creativity. The enduring impact of his life shows that Einstein was not only a scientist of extraordinary ability, but also a voice of conscience and a figure of inspiration for generations. In physics, his legacy remains central. Relativity continues to underpin modern cosmology, guiding research on black holes, gravitational waves, and the expansion of the universe. Satellite systems, global navigation, and advanced communications rely daily on relativistic corrections, proving that his insights were not abstract curiosities, but practical necessities. Quantum mechanics, the field he once challenged, has advanced in ways that both confirmed and extended his influence, particularly in quantum computing and communication. In every corner of modern physics, Einstein's presence is felt, whether in equations on a chalkboard or in the functioning of global technologies. Beyond science, Einstein reshaped how the world understands knowledge itself. He demonstrated that discovery is not the product of memorization or conformity, but of imagination, persistence, and the courage to question assumptions. His life reminded humanity that creativity lies at the heart of progress, and that even the most familiar truths can be reimagined. This message has inspired countless students, scientists, and dreamers to look at the world with curiosity and boldness. Einstein's moral legacy is equally enduring. He stood against militarism, nationalism, and prejudice, using his fame to advocate for peace, justice, and equality. His warnings about nuclear weapons remain relevant in a world where the dangers of conflict persist. His denunciation of racism in the United States and his support for civil rights continue to resonate as struggles for equality unfold. His call for international cooperation finds new relevance in addressing global challenges such as climate change, technological ethics, and shared responsibility for the future. As a cultural figure, Einstein transcended the boundaries of science. His face, with its wild hair and gentle expression, became an emblem of genius recognized across the globe. His name entered language as shorthand for intelligence. His words circulated as guides to creativity and humility, and his story inspired art, literature, and film. He became a bridge between science and everyday life, reminding people that discovery belongs not only to specialists, but to all of humanity. Einstein's enduring impact lies in the unity of his legacy. He was at once a pioneer of science, a philosopher of meaning, and a moral advocate for peace. His life showed that intellect and compassion are not separate but intertwined, and that true greatness requires both knowledge and responsibility. He remains a figure who inspires wonder at the universe, while also reminding humanity of its obligations within it. In reflecting on Einstein's life, the world sees not only the story of one man, but also a testament to human potential. His journey from a quiet child in Ulm to the most celebrated thinker of the modern age illustrates the power of curiosity and perseverance. His theories opened the cosmos, his words urged compassion, and his image inspired imagination. Today, as humanity faces challenges, both scientific and social, Einstein's legacy endures as a source of guidance and hope. His discoveries continue to expand the boundaries of knowledge. His moral voice continues to call for justice and cooperation, and his story continues to inspire generations to ask questions, seek truth, and imagine boldly. Albert Einstein's impact is not confined to the past. It lives in every equation tested, every student inspired, every act of conscience guided by reason and compassion. His life remains a reminder that the pursuit of understanding is inseparable from the pursuit of humanity, and that in seeking to unravel the mysteries of the universe, we also discover the responsibilities of being human.